Welcome to the Mastering Selenium Testing Tools video course by Pact Publishing. This course was authored by Thomas Sundberg and Ripon Al-Wazim. I am Paul Bailey, the voiceover artist for this course, and will be Ripon Al-Wazim's voice throughout the course. Thomas Sundberg is an independent consultant based in Stockholm, Sweden. He has a master's degree in computer science from the Royal Institute of Technology, KTH, in Stockholm. Thomas has been working as a developer for more than 25 years. He is a frequent speaker at various conferences and developer venues. Thomas runs a blog where he writes about programming, software craftsmanship, and whatever problem he wants to share a solution about, which can be found at thomassundberg.wordpress.com. You can also follow him on Twitter at Thomas Sundberg. Ripon Al-Wazim is very fond of test automation. He has over 13 years of professional experience in the software industry, both in development and testing. He is an active participant in the professional community of Stack Overflow. He has been one of the reviewers for the following books published by Pact Publishing: Selenium WebDriver Practical Guide, Performance Testing with JMeter, 2nd edition, and Mastering Selenium WebDriver. This is video 1.1, Course Overview. In this video, we'll just take a glance at all the topics we'll be covering throughout the course. So, let's see what the course has to offer us. The first section is dedicated for choosing and listing the various types of ingredients and making your desktop environment ready for development. We will collect all the necessary tools that we require on our journey on this advanced course on Selenium. In Section 2, we will go through the details of Selenium IDE, a Firefox plugin. WebDriver, the most important and vast topic of Selenium, will be covered in Section 3. In this section, some of the examples of WebDriver with Java will be executed from simple to advanced level implementation. In Section 4, we'll look at behavior-driven development. BDD has been focused in the perspective of business-facing by using Cucumber. In Section 5, we will look at how to use the Selenium server for remote testing as well as cross-browser testing. It can be done internally as well as externally. A complete example will be implemented in Section 6 by using Cucumber integrated with Selenium WebDriver. We will use Git for source code management, SCM, and Jenkins for continuous integration. In the final section, we will cover the advanced usage of Selenium and revise what was covered throughout the course. Mastering Selenium Testing Tools. I hope you're ready for what's about to come. Let's dive right in. Hi. In the first section, we will focus on setting up the platform. We will also take a look at the struct tools, preparation of our environment by using various tools, frameworks, and plugins. Then, we'll take a look at a small example and the architecture overview on Selenium. Our first video will be a broad overview of the tools that you will need to learn how to use during the course. The details needed to master these tools will come later as well. Here, we are just setting the stage. Let's take a step back and see what Selenium is, and view the problem that Selenium Tools Suite can help us solve. Selenium is all about automatically controlling a web page on all various web browsers such as Internet Explorer, Firefox, or Chrome. In other words, operating a web browser through a script. Controlling a web browser like this enables us to automate testing of web applications. The ability to automate browsers enables us to automate testing of web applications, including cross-browser testing to a certain extent. This in turn helps us put applications to production faster, with a greater confidence of having less broken features. Test automation reduces the time to market new features. We'll demonstrate the use of many different tools, frameworks, plugins and languages over these videos. We will explore the Selenium IDE, WebDriver, and Selenium Server thoroughly in due course. So far, we've taken a look at the tools and plugins we'll be using throughout the course. Brace yourself as we start this exciting journey. We'll soon be touching upon Java, JUnit, Maven, IDEA, Firebug, and XPath. One thing they all have in common is that they are all free and open source. You'll be able to get hold of them from the internet. In the next video, we'll take a deeper look at the tools, frameworks, and plugins we'll be using. Join me there. Welcome to video 1.3 of this section. In the previous video, we've taken a look at the various tools we'll be using throughout the course. In this video, we will take a deeper look at the tools, frameworks, and plugins that we spoke about in the last video. Let me start with the Selenium IDE. It's a plugin to Firefox that will allow you to record a journey through a web application and replay it. Selenium IDE also supports saving of the recorded items as a test case as well as a test suite. It lets you export recordings to various language-supported scripts such as Java, C#, Perl, Python, and so on. You will also be able to assert the presence or abundance of elements and texts in your page. Selenium IDE is a great place to start. While it's good to get you off the ground, Selenium has other offerings, like Selenium WebDriver, that give you greater control over what you want to test and how you want to test it. These offerings have implementations in various programming languages, which helps overcome the shortcomings of Selenium IDE. To be more flexible, you need a programming language and be able to control a browser with the help of it. Automating Selenium through a programming language can be done with WebDriver and Selenium Server. Once you write a piece of code, you may execute it locally using WebDriver or remotely using Selenium Server. You typically open up the web app, use it, and verify an expected change that you could observe. You may choose from any of these programming languages for controlling a browser with Selenium. I will use Java for our course, it being my personal preference, but you can go ahead with any other as you wish. As I said, I will be using Java. You may wonder, will this be a problem if you don't know a lot about Java? My answer is, I hope not. If you don't know anything about Java, then I suggest that you read up a little bit, at least enough so you can write your own Hello World. There are many books and online tutorials for learning Java that you can get by searching. Here are a few references you can take a look at. Java, the complete reference by Herbert Schmidt, tutorialspoint.com/Java, learnjavaonline.org. If you know how to write Hello World in Java, then I think you'll be fine. We will not use any complicated Java syntax, and everything will be introduced in small steps. Selenium doesn't offer any default verification framework. You will have to select one yourself. I will use JUnit in this video course. JUnit is a well-known unit testing framework in Java. You can download JUnit from the following site: junit.org. For Maven repository, mvnrepository.com/artifact/junit/junit. You can choose some other framework if you like. TestNG or Spock are the other two candidates. Some other languages that you can use rather than Java are RSpec in Ruby, Nose in Python, NUnit, and MSTest for C#. Our scripts must be compiled and executed. This can be done from a command prompt. It is, however, a lot easier to use a build tool. We will use Maven in this course. Maven will help us handle dependencies, compiling, and running our scripts. To know the details about Maven, you can go through maven.apache.org/guides/getting-started/maven-in-5-minutes.html. Another one is tutorialspoint.com/maven. Editing a Java program can be done using any text editor. I prefer IntelliJ IDEA. It is a free Java IDE, but you could easily use any of the other popular IDEs available, such as Eclipse, NetBeans, Sublime Text, and much more. There are two different versions you can download: Community Edition, free, and Ultimate Edition, paid. You can download from the following site: jetbrains.com/idea/download. I use the community version in this course. If you want to support the development of IDEA, then you can purchase the Ultimate Edition. In this video, we have taken a look at a few of the tools, frameworks, plugins that we are about to use in a bit more detail. That was a lot about the development environment. We need two more tools to complete our toolbox: Firebug and FirePath. Let's check them out in the next video. Welcome to the last video in this section. In the previous video, we discussed a few of the tools and plugins we'll use throughout this course. The key to getting up to speed with automating web pages is to precisely know how to access those elements in the DOM programmatically. Two of the tools that come in handy here are Firebug and FirePath. In this video, we'll take a look at Firebug and FirePath in detail. Firebug is a Firefox plugin. It will make our life easier when we examine the web pages we will automate. Finding the ID or name of an element that you want to interact with is a lot easier with Firebug compared to most other tools I have tested. FirePath is a Firebug plugin that will help us find the xPath as well as the CSS selector to an element we want to interact with. With these tools installed, let me show you a small example of what we can use them for. Let's search for Selenium on Google in two of our favorite browsers, Chrome and Firefox. We will run the example from the command line using webin. Before execution, let's meet IntelliJ IDEA, a well-known Java editor with our example source code. This is an example from the Maven project. We won't go into a detailed code analysis here. The main purpose here is to run the code from the command prompt. pom.xml will manage the beat by providing the necessary dependencies. There are two dependencies. One is Selenium Java, and the other is JUnit. The name of the Java class file is Google search _ff_Chrome test. The Java class file has two methods, one for Firefox and the other for Google Chrome. The method test Firefox will run the Firefox browser, and the method test Chrome will run the Chrome browser. Now is the time to run the program from the command line. Let's go to the Chrome command line for executing the test script. Now let's go to the project folder and execute the Maven command, maven clean test. There you go. Our test ran successfully. This is what it's all about, automating the execution of a browser. Now that we have seen what it is all about, let us look briefly at the architecture. A browser receives the command from a script. The commands are executed, and the result is reported back to the caller. The caller can be either Selenium IDE or a programming language. The result can be verified with a verification framework. We will be using JUnit in this course. Selenium is a set of tools that helps you automate web applications. You automate the browser to interact with the application, in effect, simulating an actual user's interaction with your system. You can control and drive different browsers and therefore do cross-browser testing and test the same application with Firefox, Chrome, Internet Explorer, Safari or Opera. It is also possible to test web applications for Android and iPhone. The rest of this course will dive deeper into all the details of the different tools and we will see them in action. That's all for this section. Phew, we've covered quite a lot. Let's see the overview of the entire course and the tools and frameworks that will help us to master Selenium. In the next section, we will continue with the Selenium IDE, a Firefox plugin that will allow you to record and replay a user's journey through a web application. Welcome to the second section. In the previous section, we got a quick overview of the course and looked at a few tools and plugins we'll need. We now know what is expected of us and what we'll gain from the course. This section is dedicated to cover Selenium IDE. In the first video, we will have a quick introduction of the Selenium IDE. This video will concentrate on Selenium IDE, its installation, what exactly is it, and why we should use it. So, let's dive straight in. What is Selenium IDE? Well, it's a Firefox plugin for recording and replaying your usage of a web application. However, why should we even use Selenium IDE? Because it's a very simple way to automate a web application. Selenium IDE will let you record a journey through a web application and play it back. It's an easy way to get started with Selenium and get a feeling of how your web application behaves and how it can be automated. You will be able to export the journey you recorded to a programming language and therefore be able to continue testing the application using other, more sophisticated tools. We shall explore the exporting process later in this section. Selenium IDE will help you find the elements you want to interact with by the element's name, ID, xPath, CSS selector, and more. Before we can use Selenium IDE, we need to install it. Let's browse to seleniumhq.org and install it from there. Follow the download link docs.seleniumhq.org/download and go to the Selenium IDE section. At the time this course was produced, the latest version was 2.9.0. Click on the Allow button and let it install. Click on the Install button and install the bundled items. Click on the Restart Now button to restart Firefox. With this, we now have the Selenium IDE installed on Firefox. Let's verify if it has been installed. To verify the installation of Selenium IDE, click on Tools menu in Firefox and you will see Selenium IDE in the sub-menu. There you go. We've successfully installed Selenium on Firefox. To summarize, we saw what the Selenium IDE is as well as installed it. In the next video, we'll see how you can put it to use. Welcome back. In the previous video, we saw what Selenium IDE is and installed it. In this video, we'll put the Selenium IDE to work. What we'll need to do here is record a journey and play it back to see if the IDE works as expected. Let's start the Selenium IDE from the Tools menu in Firefox. The Selenium IDE opens in the recording mode. The light red circle at the top right corner, or you may check the Actions menu, whether the record option is tick-marked. So, let's go to www.seleniumhq.org. Follow the download link, scroll down a bit to reach the Selenium IDE section. Here, click on the Release Notes link. We'll see how to verify the page title of the release notes. Right-click anywhere on the page and select Assert Title. The verification from the Assert Title has been recorded. Let's right-click again and explore all of the available commands. As you can see, there are quite a few of them. Let's go to the Selenium IDE. A few commands have been recorded, of which the last one was Assert Title. Now, let's save the recorded test case by going to File, Save Test Case. Let's name it Selenium HQ Example and select type as HTML. Now, it's time to run our test case. Just click on this green arrow whose tooltip is Play Current Test Case. As you can see, the test case is being run. And our test case has passed. You can see the log here. Now, let's check if that title really is asserted. Let's change the value from cell.de release notes to, say, packed. We will save the original text in the clipboard before we replace it. Let's run the script again to see how it behaves. It should fail. Let's click on the green arrow again. And our test case has indeed failed. The red bar indicates that it failed. This failure of the test case is our success, because our target was to fail the test case. Now, let's revert to the original test case and run it. There you go, it passed. So, it's certain that assertion has been executed well. So we are able to verify the title. If, in case the title is incorrect, the execution fails. So to conclude, we've seen how Selenium IDE works, and we played around a little with it. Great job, guys! We now have an easy tool to record and replay with. In the next video, we'll get more insight into the Selenium IDE and understand how to efficiently use it. In the previous video, we've already seen that Selenium IDE is a great tool that can help us record a journey through a web application. In this video, we'll take a closer look at the Selenium IDE. The Selenium IDE surely has great features. However, it's not capable of repeating things. We don't have access to conditions, so we can't behave differently in almost similar situations. It is not possible to reuse steps in many test cases. To be able to do these things, we need a programming language. Luckily, we can use the Selenium IDE to export our test case to various programming languages, such as Java, C#, Ruby, Python, and much more. A programming language will give us access to repetition, conditions, and easy reuse of functionalities. Earlier, we saw that we had the opportunity to choose from a verification and an assertion. So what's the difference? Assertion is fail fast. That is, the script will stop immediately. Whereas a verification is not fail fast, and other verifications on the page can be done even if the first one fails. We can use this and start by asserting that we are on the right page before we start verifying different elements on the page. It is not ideal to verify elements on a page if we aren't on the right page. Combining assert and verify can give you better scripts. Let's dive a little deeper into Selenium IDE. We'll take a look at editing our scripts, exporting a script to a programming language, test suite, and uninstalling Selenium IDE. Start Selenium IDE from Firefox and open the test case we recorded a while ago. File, Open, Selenium HQ Example. Now there are two tabs in Selenium IDE for editing scripts, Table and Source. Editing a script can be done in two different ways in Selenium IDE. Changing the order between the steps is just a matter of moving the rows up and down in the table view. We can drag the rows down and then back up. The reference menu at the bottom of Selenium IDE will give you a context-based help if you use the table. You can also edit the script you saved earlier by editing the HTML code. Using HTML may be even easier as compared to working with the table. You can also use the external editor to edit the HTML. Let's export the script to a programming language now. Let's go to File, Export Test Case As. We'll export this test case as Java, JUnit 4, WebDriver, and save it as Selenium HQ example. After exporting, open it in Editor and look at the code. Let's make a note of a few things here. The example is present in a package called com.example.tests. The class is called Selenium HQ example. Here we have a before method, a test method, and an after method. Let's take a look at each one of them individually. This is a before method. The name of the method is setup. This is a test method, named test Selenium HQ example. And the after method, called teardown. We also have three unused private methods. Private boolean is element present. Private boolean is alert present. And private string, close alert and get its text. This is a good start. Some of the stuff will be changed, but we'll come back to it at a later time. Now we will concentrate on Test Suite in Selenium IDE. You can combine two or more test cases into a test suite. This is a way to verify many different things and can perhaps be seen as a way to reuse functionality. It is not as flexible as using methods in a programming language, but it can work. We have one test case that we recorded earlier. Let's create another test case. Let's create a new test case. Select our newly created test case and ensure that it is in recording mode. Now, let's go to seleniumhq.org. Go to the documentation page and select Test Suites under the Selenium IDE section. Let us verify the page title again. Right-click anywhere, and here it is. Our title is Assert Title, Selenium IDE, Selenium Documentation. It has been recorded. Let us save it again. File, Save Test Case As. Let's name it Selenium HQ Example 2. This time, however, let's save it with an HTML extension. So, we have two test cases. And now, it's time to create a test suite. Let's go to File, Save Test Suite As, and name it Selenium HQ Example Test Suite. Select the Type As HTML and save it. We have saved the test suite successfully, and it's time to run it. To run the test suite, click on the second green icon whose tooltip is Play Entire Test Suite. Click it and observe. Great! So we have two test cases, and after executing them, they have successfully passed. You can see the green bar and the log. About the base URL, you can find it here at the top. If you want to run the same scripts on different servers, just change the base URL. You could point to acc.seleniumhq.org for testing the acceptance testing environment, or it will point to www.seleniumhq.org to run on the production site. Installing Selenium IDE was easy. It turns out that it is almost as easy to uninstall it. Before uninstalling it, let's check how to disable Selenium IDE. To disable Selenium IDE, let's go to Tools, Add-ons, Extensions. Click the Disabled button for Selenium IDE 2.x.y and click on the Restart Now link. Once Firefox restarts, the Selenium IDE is disabled. You can check it by going to Tools and observe the sub-menu. The Selenium option is no longer present. If you wish to enable it again, go to Extensions. You'll find a greyed out Selenium IDE option. Click on Enable, restart Firefox, and you'll have Selenium back in action. Now, let's uninstall it. The Remove button on the very right uninstalls Selenium. Once we restart Firefox again, you'll see that there are no traces of Selenium left. For more information on Selenium IDE, these links should be very helpful. www.seleniumhq.org/docs/o2_selenium_ide.jsp or docs.seleniumhq.org/projects/IDE. Selenium IDE is good enough for simple, static pages. However, responsive applications are not something Selenium IDE is very good at verifying. Selenium IDE is a good place to start, but it's not a place to stop. This is not the tool to automate testing of complicated websites, or do complicated testing that requires logic in the test cases. With that, we come to an end to the second section. In this video, we covered a lot of important pointers about the Selenium IDE that will help us in this journey of mastering Selenium testing tools. In the next section, we'll touch upon a very crucial part of our course, the WebDriver. Stay glued! Welcome to the third section of this video course, Selenium WebDriver. We will look at WebDriver in this section. WebDriver is a library that will allow us to control a browser from a programming language, such as Java, C#, Ruby, Python, Perl, PHP, and much more. Python, Perl, and PHP I have abbreviated as 3P. Instead of controlling the browser from a Firefox plugin, as we did in the previous section, you will now be able to do the same thing using your favorite programming language. Let's begin our journey to understand WebDriver. In this video, we shall look at a few programming languages and some tools of WebDriver. So, what is WebDriver? And what is the problem WebDriver helps us to solve? WebDriver enables one to automate the testing of your web application and to find any regressions before one deploys a new version of your application. WebDriver will allow you to automate the testing of your web application using various browsers such as Safari, Chrome, Internet Explorer, and Opera, as well as Firefox. This will save you a ton of your time. Why would you want to use a programming language? There are many reasons for this. Flexibility. A general purpose of using a programming language is its flexibility. You can do almost anything with it. At least anything you can do with a computer or device. Selenium IDE will only allow you to use Firefox, whereas WebDriver will enable you to use any browser. Automation. The idea here is to create tests with your programming language for small operations. These small tests can be used to automate small things. These small things can then be combined into larger chunks, and after a while, you may end up with a completely automated test suite of your web application. Automatic testing with the help of WebDriver can be done in many environments, such as various OS and browsers. It can be run in CI by scheduling. In the previous section, we discussed that Selenium IDE was a place to start, but not a place to stop. WebDriver is the place to continue after Selenium IDE. WebDriver is the result of merging two competing projects that solved the same problem. the control of a web browser remotely. Selenium version 1, also known as Selenium RC, injected JavaScript into the browser and controlled it that way. Then, Selenium RC was upgraded to Selenium WebDriver, which used the browser's native interface to control it. Later on, both these two projects were merged, and the future is called Selenium 2. WebDriver is a proposed W3C standard, and it hasn't been accepted yet, and is therefore currently a draft. Why is that important? It's important because when it gets accepted as a standard, all browsers that claim that they are W3C compliant must implement support for WebDriver. This in turn means that we will be able to automate all browsers using WebDriver. That would be pretty awesome. WebDriver supports many programming languages. There are libraries for Java, C#, Ruby, Python, Perl, PHP, JavaScript. This means that you will most likely be able to use your favorite language to automate your testing. I prefer using Java, so I'll use it in this course. If you haven't installed Java on your computer, now is a good time to install Java. After the installation, set the correct path for Java. Go to oracle.com, download and install Java JDK. Make sure that it is the JDK and not JRE, Java Runtime Environment. When you are done, open up a terminal or command line window. Type and execute the following command to verify the Java installation: Java-version. It should tell you about the Java version. If it doesn't work, check your path and ensure that it's working. You will not be able to follow the examples here on without a working Java installation. It is also important that you are able to compile a Java program. Verify it by running one. javac-version. This will tell you your Java's compiler version. Let me set my path correctly, and you can follow if you haven't already. Go to Properties, Advanced System Settings. Go to the Environments Variable tab. Set the path value C:/program files /java /jdk 1.8.0 _05 /bin in user variables. Set the class path value as .:c:/program files /java /jdk 1.8.0 _05 in system variables. And let's set java_home value as C:/program files /java /jdk 1.8.0 _05 at system variables. We have now set the path for Java and Java-version, and javac-version should work well. Most of the examples will be implemented using JUnit, but they can obviously be implemented in a main or any other testing framework, such as test-ng. We will add JUnit as a dependency to the projects we create. We will also use Maven as our build tool. This will enable us to simplify the dependency handling and create small examples that are easy to implement on your own without creating or handling too much infrastructure. Some people are not comfortable with Maven. If so, feel free to use something else that solves your problems better. Gradle could be a great candidate. However, we will use Maven and suggest that you do the same. If you haven't installed Maven yet, now is a good time to do it. Go to maven.apache.org. Download and install it. After the installation, do verify the installation via the command line. Maven is installed on my machine, and the class path is already set up. Let's go to our terminal and type and verify it. Type mvn-version. So we're using Maven version 3.3.3. You can also verify the version using the command mvn-version. Now that we have installed Maven successfully, let's set up the Maven path. Right-click on my computer, go to Properties, Advanced System Settings, Environment Variables. Please set your Maven path as shown. The folder should be set as Apache-Maven-3.3.3 with variable name as m2_home. Also, set the path as %m2_home%/bin at user variable. So this is how we set up Maven class path and Maven home after installation. I hope you have noticed that we have preferred using the command line in some situations. The simple reason for this is the fact that using command line tools enables us to automate a lot of the things we do. We can write small scripts for common tasks. Later on, it also allows us to integrate these tools in a continuous integration server. WebDriver for Java is updated frequently. It seems to be updated about once a month and has been updated this often for the last 3 years. In this video, we have installed Maven, verified it, and set its class path. Join me in the next video so that we can actually go through some implementation. See you there. Welcome to the second video of the third section. In the previous video, we introduced WebDriver and discussed its benefits. Now, let's get our hands dirty and actually implement something in this video. The question is, of course, what should we implement that is small to begin with and is still valuable? Let us verify that we can navigate to the WebDriver documentation and verify that we have arrived at the correct page. This means what we need to do is go to www.seleniumhq.org. Click on the documentation link. Then click on Selenium WebDriver link. The last thing we do is to verify the page title that is expected, which is the title of the WebDriver documentation. Before implementing this example, I have prepared a Maven project that will help us run this example from a command line. Another great thing with using a Maven project file is that we can use our IDE. I prefer IntelliJ IDEA to open the POM project object model, and we will get a project where all dependencies we need have already been prepared. Notice that we don't need to import the project file. We just need to open it. IntelliJ IDEA and Maven integrate very nicely with each other. Our first code implementation is the Java class file, WebDriver documentation test_01 Java. Unfortunately, this is a poor example because all the concepts are mixed up. Location of web elements, navigation, and verification are different things, and they are mixed up here. This mixing is bad because it will be unnecessarily difficult to maintain this test. But bad or not, this is the way a lot of Selenium tests look like. The good thing is that it's possible to clean up. Let me introduce you to some abstractions, so we can make a difference between navigation and validation. We have extracted navigation method in WebDriver documentation test_02.java file. There are two methods. One is for navigation and the other is for validation. Now is the time to do some more refactoring. Let us take a look at the methods we extracted earlier to the new classes. These classes are SeleniumHQ.java, documentation.java, WebDriver documentation.java. These are all available for page navigation. And the test class WebDriver documentation test_03 Java, which is responsible for performing the verification of assertion. As the single responsibility principle says, that every context, class or function should have a single responsibility, and that responsibility should be entirely encapsulated by the context. In other words, do one and only one thing. In this case, do navigation and only navigation. These new classes are examples of page objects, a page object that is responsible for navigation and interaction with the web pages. We will discuss page options in more detail at a later time. We didn't really gain anything in terms of less lines of code in the test, unless we chain the methods and invoke the next step on the return value. Let's see how it works. Selenium HQ file transits to HQ homepage and returns the documentation page, and the documentation file returns the WebDriver documentation page. Finally, in WebDriver documentation test_03, we have changed some methods of page objects and performed the assertion. This is the chain of these objects' methods, and we have done assertion here. A little and final refactoring on WebDriver documentation _04 test. There is a problem that we want to address before we move on. Firefox will not be stopped if the test fails. JUnit works by sending exceptions, and if we have any problem with the navigation, or if the assertion fails, we will end up with orphaned browsers. These browsers will have to be killed manually, which is a bad thing. We will address this by implementing one method that will always be executed before a test, and another method that will always be executed after a test. The @before method will always be executed before each test. The method containing @before, the JUnit annotation, will always be executed before each test. The method having the JUnit annotation @after will be executed after each test, even if the test fails. This is exactly what we want. No matter what the result is, we want to quit the browser. Focus on the name of file WebDriver documentation _04 test. It has a suffix test, because Maven will execute those files which has the suffix test. Let's run this example so we can ensure that it still works. Shift plus right mouse click on project folder. Select Open Command Window here from the context menu and execute the Maven command mvn clean test. Build successful. So it passed. I wonder if this was pure luck. Let's check that. Let's change the expected page title to something incorrect. Open the file WebDriver documentation _04 test. And let's change the page title from Selenium WebDriver - Selenium documentation to Mastering Selenium Testing Tools. Let's save and run again. Now, let's go to the command prompt and execute the Maven command again. Build failure, which means it didn't pass. This is enough for us to know that the assertion executed works, as it initially passed, and after modifying the title, it has failed. Please revert and assert the correct title. One of my colleagues recently said, "I was very careful running things often with just small changes between each run." However, I'm not sure if that is being careful or just playing it safe. I think I prefer the latter, playing it safe. I don't like it when I break things, and I want to know that when I break something, it should be easy to understand why. In a perfect world, there would only be one thing that could be broken when a test breaks. However, in reality, that might not be the case. The best way to go about it is to make small changes and run it. You can corner in on the issue and fix it well in this manner. All we had to do was create this small Maven POM. We need a few things to build this example, however nothing from Java. We need the Selenium libraries and JUnit. These dependencies are easy to specify in a Maven POM. Maven will download the missing dependencies if they haven't been downloaded from the central repository, and we will be able to use them. You might feel that Maven downloads half of the internet for the first time you use it. However, the dependency handling that Maven offers out of the box is very handy in examples like this. In this video, we have implemented our first example using Selenium WebDriver. Join me in the next video where we will delve deeper into the capabilities of WebDriver. Welcome to the third video of section 3. In the previous video, we saw a small example where we used WebDriver to locate and verify its own documentation. In this video, let's go ahead and take a look at some more features of Selenium WebDriver. Let's take a look at the list of browsers WebDriver supports: Firefox, Chrome, IE, Safari, Opera, HTML Unit, iPhone, and Android. You can check the following page for more details regarding browser support. In this case, a WebDriver is the same as a browser. You may have never heard of HTML Unit as a browser. HTML Unit is a headless browser implemented in pure Java. Headless means that it will not show anything on the screen. It's non-graphical. HTML Unit is therefore one of the fastest browsers we can use to implement a test. It's a great tool when you don't really need the graphical experience when it comes to using an actual browser. You can also use Phantom.js for the same purpose. HTML Unit is probably not a great alternative if you wish to implement cross-browser testing. That is, test your web application using many different browsers. There are also drivers for iOS and Android. These can be used to test web applications on iPhones, iPads, and Android devices. The iOS and Android drivers are not meant for testing apps on these devices. They will only test web applications with the help of native browsers. The secret behind supporting so many browsers is that they all implement the same Java interface. That is, they must all implement the same methods. WebDriver has a small interface. It doesn't really implement a lot of methods. This is the largest difference between Selenium RC and WebDriver. Selenium RC has a very large set of features. Many of them were syntactic sugar. The WebDriver API is much smaller. In this video, we have skimmed through a few features of WebDriver and glanced at a few browsers that WebDriver supports. Let me walk you through the WebDriver API in the next video. Join me there. Welcome to the fourth video of the third section. In the last video, we had a look at the browsers supported by WebDriver. Let's move further in this video and walk through the WebDriver API. The WebDriver Java doc is available at selenium.google-code/git/docs/api/java/org/openqa/selenium/webdriver.html. Get does pretty much what it says. It uses the HTTP method get to navigate to a URL. Get current URL will return the current URL as a string. This can be very handy if you want to verify that you have navigated to the right page. Get title will return the title of the web page. This is also a great way to ensure that you're working with the right web page. Find elements will return a list with all elements that matches the search criteria. This is great if you need to examine a radio button group to see which radio button is selected. Find element does the same thing as find elements, but it will not return a list of elements. It will return one element that matches the search criteria. If there are more than one element that match, then only the first element will be returned. getPageSource does pretty much what it says. It will return a string with all the source code for the page. Unfortunately, the page source returned may differ between driver elements. JavaScript executions may also make the returned string different between executions. I usually use the source for troubleshooting and not much more. Close will close tabs in your browser. If the current tab is the last one, then the browser will be closed as well. This doesn't seem to work as advertised with Safari. The browser still lives after it has been closed. This is, on the other hand, the expected behavior on a Mac. Just closing a window doesn't kill the application. Quit will kill the current browser. You want to make sure that the browser is killed when you are done. Otherwise, you may end up with orphaned browsers that you will have to kill manually. getWindowHandles will return a set of Windows handles. You can iterate over these handles and use them to switch browser windows. getWindowHandle will return the current window, so you can switch back to it later. Switch to will switch to another frame or window. This is probably something you want to do when you have found the right window handle. Navigate will allow you to use the browser's history and navigate to a given URL. Manage will get you access to a set of methods where you can manage different browser options. These options include handling cookies, logs from the browser, and fiddling with different input methods from the IME handler. These are the methods a WebDriver instance must support. As you can see, it isn't really a large interface, but it is powerful enough to solve a lot of the common things you want to do. The next thing to examine will be the by class that you can use to locate elements with. Join me in the next video. Hello and welcome to the 5th video of Section 3. Locating elements is one of the most important things you will do. We can't do anything without interacting with the elements first, so locating elements is very important. Locating elements is obviously done differently depending on your location strategy. We can locate an element present in the page by searching for its name, ID, link text, class, or we can use a structural way to search for elements. Structural searches are done by xPath or by CSS. Let us go to the documentation. We will use the class by and one of its subclasses to locate elements. Which subclass to use obviously depends on the way you will execute the search. The by class will allow you to locate elements using one of 8 ways. Which one of these you'll end up using the most depends on your web application. I prefer to use an ID if possible. By name is my second choice. XPath and CSS are common too. They will always be an option, but they are harder to use compared to name and ID. Locating elements based on their link text, or for that matter, partial link text, can work, but may be fragile. It is worse to use the link text if your application is internationalized. The text on your web page will be changing with the language, and handling that in your code can be very difficult. It is possible to locate elements using different language classes and tag names. This may be a good alternative if you want to find many elements and do something with all of them. We will see some usage of the different locators in this course. It will hopefully be obvious which selector you will use after a while. Let us look at all the different ways to locate an element. Let's start with by class name. It finds elements based on the value of the class attribute for the element you are looking for. This may work great if the class is used for only one element or a small set of elements. It will probably not be great if you have many elements with the class. The next locator is By CSS Selector. By CSS Selector is similar to the class locator. It can be great if you only have one or a few elements that can be located by a CSS expression. It may be futile and brittle if you use the same CSS for many elements. The next locator is perhaps one of the best ones, by ID. It will locate elements by its ID and therefore immune to things like different languages on the web page. It's fast and usually very reliable. The only setback may be that some web applications don't use IDs for elements as much as they perhaps should. If this is the case in your application, make sure that you speak to the developers and show them why this is important. Any reasonable developer will help you and add IDs where they are needed. The next locator is by link text. This is the locator we used in the small example earlier. It is reliable when the web page is in one language. It is not the best choice if the language on the page varies. By name. The by name locator is just as good as the ID selector. It doesn't always exist, but when it exists, you can choose any of them. By partial link text is similar to the link text locator above. It has the same weaknesses regarding internationalization. Use it when you have to, but be aware of the fact that it can be unnecessarily brittle. The next one is by tag name. Locating elements by their tag name is yet another option. I use it rarely as the tag names are not often unique. But at the same time, it is great if you want all the items in an unordered list. It has its use cases, but perhaps less common compared to some other locators. By xPath. The last locator is locating elements by xPath. It is very powerful and therefore not always that easy to use. XPath is a way to search in XML files, and HTML is a variant of an XML file. It is brittle if the structure of a page changes. It is also slow on some drivers. It happens so that by XPath is the only way you can use to locate an element. If you have explored all other locators and found that none of them will do the job, then resort to the XPath locator. It should, however, not be your first choice. In this video, we've taken a walk through the 8 different ways you can use to locate elements. You will probably find your favorites and use them a lot. The most stable locators are locating by ID and name. Be careful when you select your locators so you don't make your navigation unnecessarily brittle. In the next video, we will examine the web element interface. Stay in touch. Welcome to the 6th video of the 3rd section. The find methods in the WebDriver return web elements by using different locators. So, what is a web element and how can we use it? A web element is an interface that implements methods you can use for interacting with elements on a page. A web element can be a text field that you can click on, type in, ask for its text, ask if it is visible, and so forth. There are a total of 15 different methods a web element implements. Let us look at the Java doc for all of them. These are the details of interface web element. Let's go through the methods. Click will, not very surprisingly, click the element. It will try to block if the click results in a page load. It will, however, not block if the click results in an event that will load the page. This could be a JavaScript event. In that case, you will have to verify the page load manually. A click is only possible if the element is visible and has a size larger than 0. Click behaves pretty much as and when you actually click on an element manually in a browser. If you can't see something, you can't click on it. Submit will submit a form if the element is a form. If the element is located inside a form, it will submit the form. Submit will block until a new page has loaded if it's the results in a new page. Send keys will send keys to the element. It will behave as if you type on a keyboard. Not all elements can receive keystrokes, so sending keys to that type of element will be meaningless. Clear will clear text entry elements. It doesn't have any effect on other types of elements. It will not fire any keyboard events. If you need to fire keyboard events, use send keys instead. Perhaps by sending backspace or something similar. getTagName will return the tag name for this element. This means the name of the tag, not the name of the element. An input tag with the name foo will return input and not foo. getAttribute will return the value of a given attribute on an element. If you have the attribute read-only set to true on a text element, getAttribute will return true. isSelected will return true if the element is selected. It will return false if it is not selected. It will only make sense on elements that can be selected, such as checkboxes, radio buttons, and options in a selection. isEnabled will return true if an element is enabled. Input elements can usually be enabled or disabled. All other elements are enabled. getText will return the visible text from an element. findElements is the same as findElement on a driver. It will return a list of elements that satisfied the location criteria. findElement is also the same as findElements in a driver. It will return the first element that was found with the location strategy that you used. isDisplayed will return true if the element is displayed on the web page. It will return false if the element is present but hidden on the web page. getLocation will return a point that tells us where the left-hand upper corner of an element is located on a page. All elements are usually larger than a point, but this is the 0, 0 location for the element. getSize will return the dimension for the element. Combining the location and size of the element will give the possibility to calculate how much of the web page that this element occupies. getCSSValue of a property name will give you the CSS value that will be applied to this element. Getting the CSS value can be great when you troubleshoot why your expected CSS isn't applied as you thought it would be. This was a quick walkthrough of the Java doc for WebElement. Driver, location, and WebElement are perhaps the three cornerstones of WebDriver that we will use the most. Don't learn them by heart. Remember that they exist and find them using your IDE. All modern IDEs will give you context help when you press dot in the IDE on a project. This will hopefully be enough for you to remember when to use them. All methods here behave pretty much as their name suggests, so using them should hopefully not be an issue. There are some more supporting methods that you can use when interacting with selects and a few more elements. We will come back to them later. We have examined the most important low-level building blocks in this video. Join me in the next video, where we will look at the next level of building blocks, the page objects. Welcome to the 7th video of Section 3. We have examined some of the low-level building blocks in the previous videos. Now, it is time to examine a larger type of building block, page objects. What kind of creatures are these page objects, and why should we care? Earlier, we saw an example of 3 different page objects. We extracted them from an example where we navigated through the documentation for WebDriver. The reason for extracting them is that we need to separate navigation and validation. We didn't want to tie the navigation through the documentation to the test. There is the simple reason behind the pattern page objects: separation. The reason for separation is that it is good to honor the single responsibility principle. That is, each thing should do one thing and only one thing. A page object is an abstraction of a page in a web application. That is, we should represent each page, or sometimes a smaller part of a page, with a Java object. This Java object knows how to interact with the page. It can return elements and values from the page so that they can be asserted in a test. The Java object contains logic that is used for interaction with the web page. It will, therefore, effectively remove any page-specific knowledge from a test that implements the flow in the web app. The next test doesn't have to be aware of implementation details, such as the name of a link that should be followed to find another page. The type of low-level knowledge is abstracted away from the test. This is very handy the day someone decides that the web application needs to be restructured. Moving things around will probably break the tests. But if all the navigation details are hidden, it might just as well mean that the test will be okay again when the page objects have been updated. The page objects should never perform assertions about the web application. All these assertions should be done in the tests that use the page objects. The page objects should be able to return the status about the page. An example could be the title or the value of any field. In our example, we have returned the text of a heading that will say at a later time. A page object may assert that its internal browser is actually pointing to the page that it's expected. This can be done in different ways, but a simple way is to throw an exception when the page object is created and the current browser is not pointing at the expected page. If you add that type of assertion, make sure that you throw an exception that is specific to either the page or your application. Don't use JUnit to assert this. If you use JUnit to assert that you are on the correct page, then you would tie the page object to a certain test library, and that would not be very wise. It is a lot better to allow the test to be written using any test library and not force the choice of test library from the page object implementation. So, we have discussed about page objects, and we have also seen an example. Let us now create a new example where we can use some already existing page objects. We would reuse some of the previous work, so we will once again verify the WebDriver documentation. But this time, we will verify the heading for the page objects section in Test Design Configurations page. Let's see what we are actually going to test and verify. Visit www.seleniumhq.org. Click on the Documentation link. Then, click the Test Design Considerations link. And go to Page Object Design Pattern section. We will verify this heading in our example. Let's start with the test and implement it using some existing page objects. Our existing page objects are Selenium HQ and documentation. We have implemented one new page object, test design considerations.java, and the test file is test design considerations test.java. Notice the easy flow when the page objects are already done. This is the way we want to implement our tests, using existing building blocks and combine them in clever ways. Using page objects that already exist will allow us to concentrate on navigating the application and verifying it without worrying about low-level details, such as how a certain element is located. This increases the abstraction level in our tests. We should use a domain-specific language, that is, the page objects, and build the test from there. This is a lot easier to maintain, as compared to a low-level implementation where we mix things like locating elements with what content or behavior we are expecting. Let us take a look at a new page object that we have added for this example. Test Design Considerations.java. This page object follows the same pattern as we saw earlier. The browser is set when the object is created. We will verify that we are on the expected page. This is an enhancement to the previous example. If we end up on the wrong page, then a custom exception will be thrown. There is a specific method that locates the page objects section on the page and returns the text in the h2 tag. This may seem like it's very little code, and it really doesn't do a lot, but it does enough for verifying the heading of the page object section. It does one thing, and it does it pretty well. All of your methods in your page objects should be similar to these small methods. If they are larger, then consider breaking them into smaller methods. This turns very easily into a discussion about clean code that is out of scope for this course. Nevertheless, clean code is extremely important in test code as well as production code. Now, let's see how is a wrong page exception implemented. It is a very small exception that really doesn't do anything. It just delegates to its ancestor to create a runtime exception with the message. But it's important not to throw a raw runtime exception. The reason for this is that if we use custom exception, it is a lot easier to understand where the exception comes from and what it represents. Then you may wonder, why didn't we use an exception? Why extend runtime exception? That question is again a discussion about clean code. A complete answer can be found in the book Clean Code, where an entire chapter is dedicated to exception handling. My short motivation here is that we wish to throw our custom exception, but don't want the surrounding code to bother that this might happen. If it happens, then we can't really do much about it, so the exception will fail. There is no good reason why we should add additional cognitive burden by forcing the code that uses this page object to handle a checked exception as well. Now let's run the example. Go to the Projects folder, press Shift plus right-click and select Open Command Window here, and execute the Maven command here. And there you go, the build was successful. The page object should represent a page or part of a page. It should be used to interact with a page, but not used when asserting some page content. Assertions should be done in the testing framework that you use. This will allow you to use whatever testing framework you want, without affecting the interaction with the page you want to test. Page objects should not be used to define the flow through a web application. The flow should be defined in a test. The flow probably means that you will use more than one page object in a test and navigate from one page to another. In this video, we have taken a good look at page objects. There are still some advantages of using WebDriver that you want to be familiar with. Join me in the next video where we will see some of them. Welcome to the 8th video of Section 3. We have now covered a lot of low-level details and use them to build high-level page objects. Let's now continue with some advanced WebDriver features. We'll cover the complexity of modern, responsive web applications that will require interacting with all the different types of components you will find on a web page. In this video, we will focus on some of the advanced WebDriver features with examples. Radio buttons have the property that only one can be selected at a time. When a radio button is selected, all the other radio buttons in the same group are unselected. A radio button group is a collection of all radio buttons that have the same name. To find out which one is selected, we need to do two things. We need to find all web elements with a given name, and we need to iterate over these elements and remember the selected element. Let's look at an example. W3 Schools has a lot of HTML examples. Let us look at their page for forms and input. Here, we have a simple radio button group where we can select either male or female. Let us input a small example where we check if the male option is selected or not. Radio button example test. This example is implemented as one single class. Instead of implementing a page object, let's divide the navigation and validation into different methods. This is for navigation, and this is for verification. The first thing we must do is to make sure that it is translated to the desired page. When we select a radio button, a male is selected by default. The actual test does two things. First, it delegates the interesting part of locating the radio button. Second, it verifies the result. Interesting things happen here. I locate the radio button group by searching for all elements with the same name, sex, on the page. With all elements in a list, we will iterate over all of them. If we find a selected element, we will return the value found in the attribute called value. This is how you work with radio buttons. Find the set of all radio buttons, iterate over it, and do something with one of them. Let us run the test individually here and observe the result in the console. The test has passed and the result is showing as expected in the console. The number of buttons is 2 and male was selected by default. Checkboxes are another input type that we must be able to work with. They are different compared to radio buttons in the sense that they can be selected independently of any other checkboxes. Checkboxes can have none, one, or many selected. Checkboxes are easier to work with. All you have to do is find it and see if it is selected or not. Let us take a look again at W3 Schools and implement an example where we interact with two checkboxes. On W3 Schools site, we can see two checkboxes to interact with, and both of them are unchecked. Let's inspect the element with Firebug. After taking a closer look, reveals that the name of one checkbox is Vehicle 1 and the other is Vehicle 2. It is easy to identify and locate each checkbox as they have a unique name. Let's implement a small example. Open Checkboxes Example Test. We will verify whether the checkboxes are tick marked or not. Our expected result should be false, as both checkboxes are unchecked. Let's run the test. The test has passed, and the expected result is shown. Both the checkboxes show false. Many of these advanced interactions have great support in the org.openqa.selenium.support.ui package. Let us look at some of the goodies located there. Let's start with the select class. It models a select tag and provides helper methods when working with selects. Let us take a look at a page where we will find a select at W3 Schools. This is a test page from W3 Schools, where you can fiddle around with a select and try different things. Let's implement a small example where we can check which option has been selected from the drop-down box. And we shall get all the items of drop-down by iteration. We will follow the same pattern from the previous examples. Let us run the select example test individually and observe the result. It has passed and shows first selected item, number of items, and list of all combo items. Now, let us concentrate on wait for page loading in Selenium WebDriver. What should we do when a page takes time to load? Suppose that we send a request that takes some time to execute. We want to verify something on the resulting page. We will have to wait for the page to load. Just locating the wanted element after the request was sent doesn't work. Let's implement a search on Google. We will count the number of results we get when we search for Selenium WebDriver. This should be a simple thing, but it turns out that it isn't as easy as one would hope. We have three methods. Should wait for page to load 1, 2, and 3. Let's implement them one by one. Let's implement the first one and execute the test. Let's go see the result. Well, the first one fails. We have called the first method from our test method. Let's run it. Well, it's failed. Now what? How can we slow down the test so the page has been loaded? Let's add a sleep method before we try to locate the result area. We will implement the sleep method in a second method. Let's call our second method from our test method. Should wait for page to load too. Let's run this example again. It should pass, as we have waited for 1000 milliseconds before loading the page. Awesome! It passed, which means it worked. That solves everything, right? Not really. This sleep will always be executed, even if the result is returned faster than the time slept. The solution will not handle efficiently if the loading takes longer time than the sleep timer either. Adding sleep time is actually a bad idea. The sleep time in your tests will add up, and the already slow tests will be even slower. What should we do then? We should use the WebDriver wait and wait until the wanted element is found on the web page. We have implemented the WebDriver wait method in our third test. Let's call this method from our test method and run the test again. This test should pass. It did. Cool, right? The problem is solved, and in a good way this time. Failures will always occur. The most important thing when a failure occurs are the parameters used, an execution log where it is easy to follow a flow, and a screenshot of the web browser. The screenshot may be the single most important clue when the reason for the failure needs to be understood. Let's see an example where we take a screenshot on a failing test. There are two things that have been done. First, do something on failure. Second, take the actual screenshot and save a file with it. Acting on failure is JUnit specific and will probably be done differently if you use another framework. Creating a screenshot is done with WebDriver and is therefore similar even if you use another framework such as TestNG. My idea is to implement a JUnit rule that will be triggered whenever a test fails. The real work will be done in the rule. Let's implement that as well. So we have implemented a screenshot rule here, and we have also created a test class called screenshotExampleTest. Actually at the rate, rule impression will do the magic. When a test fails, it will be called screenshot rule. So, in our test class, we have implemented a LinkedIn registration, and intentionally we have made an error in the ID of last name so that it should fail. And when a fail occurs, a screenshot will be captured in our desired location. Let's run the test and see the result. As we can see, the test has failed and a screenshot has been captured. Let's check the reason for this error. It says, unable to locate element, method ID, selector, last name. The test was created because of the ID of last name was incorrect. In this line, let's observe the screenshot that has been captured in the desired location. In our case, the screenshot will be placed at the following location: D, Drive, Test folder. Let's see the screenshot. Cool. Now we have a screenshot whenever a test fails. In this video, we've taken a look at a few advanced features of WebDriver. It happens that you need to move between different windows when testing a web application. In this video, We'll aim to resolve this issue and see a few more features. Let us see an example of how you can hold a list with all windows available and then change the focus between them. We will implement an example where we open up two windows in Firefox, open up the Google search page in one of them and Bing in the other. This is the multiple window example. Here we have two methods: open first window and get new window. In the first method, we'll open google.com, and in the second, we'll open bing.com. We have to save the window handle for the first window before we can create the other window. We will do this so we can switch between them afterwards. With two window handles pointing at two different windows in Firefox, we can call the switch2.window open brackets close brackets method with the window handle to which we want to give focus. After opening the Bing window, we will switch to the Google window again by using driver.switch2.window and the parameter in the window Google, which is a variable of window handle. Let's run it. The first window is Google, and the second is Bing. And again, we have focused on Google. Let's observe both windows. So, it worked. Great, isn't it? It turns out that this is very similar to the way you move between iframes as well. Let's go back to the select example and look at the switch2.frame. In this case, we didn't have many windows to handle, but we did have an iframe to move ahead if we could find the select that we were looking for. I wanted to open up a new window in the previous example. One way to do that was to execute the JavaScript. Window.open. WebDriver supports running JavaScript if the browser you use supports JavaScript. The JavaScript will be executed in the same context as your current window of frame. This means that we were able to get a new browser window when we did window.open. Let us examine the getNewWindow method. In the multiple windows example test, we will start with casting the browser into a JavaScript executor. This will fail if the browser doesn't implement the JavaScript executor interface. When we have a JavaScript executor, we should invoke our script through the executeScript method. Looking at the Java doc, let's observe the JavaScript executor interface. It tells us that most browser drivers implemented. We have seen many different ways for locating elements on a web page. We haven't seen any example where we use xPath. But before we dive into an example, let's get familiar with what xPath is. xPath is a search language that you can use for searching in XML documents. HTML is XML too, so searching for elements in HTML can be done using xPath. There are two problems we may encounter while executing a search using xPath. The first one is that the slightest change in the structure of the web page can affect the result and makes your xPath search invalid. The second one is that it is a lot more complicated as compared to locating elements using their name or ID. An xPath tutorial can be found at the following link. It is out of scope for this video course to go through all the details about xPath. However, you can go through the link and learn on your own. There are tools that will help you to find the xPath to an element. I use Firebug a lot for examining web pages. A Firebug extension is called FirePath, and it will allow you to search in web pages with xPath. It is nice, but the killer feature of FirePath is the possibility to point an element and get the xPath for it. Let's see an example on how we can locate the heading xPath tutorial with FirePath. This is the xPath tutorial heading. Right-click on xPath tutorial, inspect in FirePath, and look at the search box. The xPath of xPath tutorial heading will be displayed in the search box. With the xPath we want, let's implement an example that locates the web element. We have implemented one example, xPath example test, by using the xPath that we have examined using FirePath. Let's run it and ensure that we actually get the text xPath tutorial. Whoa, we got it! The heading of xPath tutorial can be seen here. This may not seem much more complicated than locating elements using the methods we have covered so far. Depending on your mileage, it may not be more complicated either. But using paths has a definite downside, and it is a fact that it uses the path structure to locate things. This means that a small change on the page can easily break everything. In other words, it may be unnecessarily fragile. I wouldn't recommend using xPath unless you really can't find the element any other way. Sometime it might need to use absolute xPath rather than relative xPath. CSS and xPath can be used as element identifiers. Both CSS and xPath of an element can be obtained by using FirePath. Moreover, CSS is faster than xPath, so it's good to use CSS rather than xPath. There are many ways to interact with a modern web application. This short walkthrough is not the end, it's just the beginning. It should have given you enough so you can start using them, but at the same time, I'm sure you will find special cases that will be challenging to resolve, that we haven't covered here. Radio buttons, which find all and iterate over them. Checkboxes, not really advanced unless they are all named the same thing. Select. Use org.openqa.selenium.support.ui.select. Wait. Wait for the object to show up. Never use sleep. Screenshot on failure. Done differently in different test frameworks. Invaluable when troubleshooting. Multiple windows. Save the window handles and switch between them as you need. JavaScript will be executed in the context of the current browser. xPath, powerful and fragile. Use with care. So in this video in all, we've covered 8 different cases. There are obviously more, but this will hopefully be enough to get you a running start. We will connect all the dots with the reality in the next video of this section. We will build an entire example with Maven. Join me there. Welcome to the last video in section 3. So far, we've covered some of the advanced features of Selenium WebDriver. Remember, there are many more, and covering everything in this course is not possible. We've taken a look at the most important ones. In this video, we'll build an entire application. All modern applications are built using a build system. We will create a complete project where we will see how Maven can be used to set up an entire project. We have built our flow using page objects in unit tests. Executing it from Maven is just a matter of running a suite of tests. It is a standard procedure when you use Maven. This is our Maven project. Let's start with the file organization. Maven is all about configuration over convention. The production code should be in a certain directory structure, the test in another. There will only be tests in this case, so we can skip creating a home for the production code. This means we need to create src/test/java/, so the test code has a home. Maven has a project file that will contain all the important details about the project. We can open the project with IntelliJ IDEA when we have a pom.xml ready. But before it exists with some content, we will not be able to use IDEA. With a pom.xml in place, let's see if we can build the project. Go to the project folder and execute the Maven command. Build success. It means it worked. Browse to the following link. Introduction to the lifecycle.html. To see the set of build phases built into Maven. As we know, Maven is all about convention over configuration. This means that we don't have to specify and build phases. There are a set of build phases built into Maven. Here is the list. All we did was execute two of them, clean and install. Clean will delete any build artifacts. Install will compile, test, package, and finally install our build artifacts. Any dependencies that are missing in each build step will be downloaded from the internet. Maven has a plug-in architecture and will download things it is missing. Let's implement a Google search. We have already implemented one earlier, but let's revise what we did. Search Google Test is our test class. The browser will be created in the method. Annotated with @ before, and it will shut down in the method annotated with after. The method annotated with @test will execute the test. It will create a page object and use it. In this example, there are two page objects, Google and Google search page. The constructor, google.java, navigates to google.com and asserts that it has arrived at the right page, or at least that it has arrived on a page that has the title Google. A wrong page exception is thrown if the page title isn't Google. Google search page.java. This is a small page object. We only want to check the number of results returned on the page, so it only has one method, getNumberOfResults. The wrong page exception must be implemented before we test whether this example can be executed from Maven. The only important thing here is that the wrong page exception must extend the runtime exception. We should avoid implementing exceptions that extend an exception, since we are convinced that checked exceptions are one of the biggest mistakes in Java. With all the pieces in place, let's rerun Maven and see if we are able to search for Mastering Selenium Testing Tools on Google. Go to the project folder in command prompt and execute mvn clean install. It worked. We have a successful build. Firefox was started and Google was searched in. This is great. We are now able to execute this test from a build system that can be part of a continuous integration. It can even be extended to be part of a delivery pipeline. Let's set up a continuous integration server and show how a change can be picked up. In an ideal world, a test project should be executed as soon as there has been any change in the system you are building. Such a practice is called continuous integration and is a standard practice in agile teams. A continuous integration server is able to poll a version control system and start a build when a change is detected. This means that we must use a version control system where we commit all changes to the code. Remember, the tests are also code and must be checked as well. These changes will be picked up and a build will be performed. We will use the simplest possible approach and use Git globally. We will also run Jenkins locally. Jenkins will be able to pick up any changes we commit and execute a build automatically. We will start with placing the example under version control. Make sure you have installed the Git. I have downloaded the Git from git-scm.com/downloads and installed it successfully on my Windows machine. Open command prompt and go to the project directory. Execute git-version to verify the Git installation. It looks okay. My Git version is 2.6.3. Now, let's execute the command git init. The system is now under version control. Let's see the Git status by executing the command git status. So, there are some untracked files. These should be added to the Git. Execute git command add space dot. Now, let's check the status again. So, all files are ready to be committed. Let's commit pom.xml first. The command is git commit pom.xml -m, my first pom.xml. So, pom.xml has been committed. Let's check the status once again. The pom.xml has been committed, and the rest of the Java files are being prepared to be committed. Let's commit those files, git commit -m, all Java files. It looks good. All the files have been committed successfully. And let's see the status yet again. On branch master, we see that there is nothing to commit, and the working directory is clean. It means all the files have been committed successfully to the Git repository. I have created a repository on github.com at the following location. We should push our code here, so that Jenkins can pull the latest code from the global repository. We should use this command to push our code in the global repository. Open the command prompt, browse to your project directory, and execute the following command. Git remote add origin git at github.com rip on al wazim /chapter3_9.git. Chapter3_9 is our global repository. Let's execute it. Now execute git push -u origin master. There you go. Now our code has been posted on the global repository. Our next step should be to start a continuous integration server called Jenkins. But before that, let's download it. I have downloaded Jenkins from jenkins-ci.org. For my Windows machine, it has been installed successfully. Go to the install directory of Jenkins and execute the following command to start Jenkins. jenkins.exe start. Jenkins is up and running. We should now have a web application on port 8080. Browse localhost :8080 in your browser. The next step is to configure a job in Jenkins. We'll call our project chapter3_9. There, we have created our project. We will also set the job to trigger on changes in the version control system. We will set it to poll every minute. Jenkins can't check for changes continuously, but once every minute should be enough for us. Our next step, when the job is in place and configured, is to commit a change and see that job is executed. Let's configure our project now. Select Git as your source code management option. Set your repository URL as follows. Enter your credentials here. I have also mentioned the repository browser here with its respective URL. Let's set up the schedule for poll SCM as 1 minute in the following manner. The root POM should be mentioned here, and the goal and options should be clean test. And that's all that is required for now. Our configuration is done. Now is the time to see the effect of any change in code in Jenkins after pushing the code on GitHub. The Jenkins job is in place and configured. Now, let's see whether the job has been executed. We'll do that by introducing an error. Let's change the title of Google homepage to an incorrect one. The correct Google title is Google, However, let's change it to something else. This is a wrong title, so an error should occur while execution. Let's commit the code after changing it. Let's check the Git status before that. As you can see, one file has been modified. It's the google.java file. Now, let's add this file to the repository. Git add space dot, press enter. Then git status, enter. The google.java is now ready to be committed. Let's commit it. Type git commit -m and add a message, wrong title of Google. The file has been committed successfully. Let's see the status again. Nothing to commit. The working directory is clean. Now let's push our code in our global repository. Type git push. So the code has been pushed. Let's observe the result now. We might have to wait a bit. The build should kick in about 30 seconds after the commit. And there we go. The build is being executed. Build number 3. We're expecting a failure as the title is wrong. And look, we have a failure. This is the failure. Wrong page exception. The bug we introduced was found. Let's quickly fix it and execute it again. Check the status. Add the file. Check the status again. Commit. And type the message, correct Google title. Let's check the status again. And finally, push to the global repository. Let's see the next build and hope that the bug is fixed. Here is the next build. Build number 4 is being executed. And it was successful. Hooray! The result for running a continuous integration system is to get fast feedback. We were able to find a bug introduced within seconds from our mistake. That is good. Speed is everything when it comes to feedback. A fast feedback loop is very valuable. Since speed is so important, we want to avoid manual testing. We would also like to avoid testing with a browser. A browser, even an automated browser, is slow compared to unit tests. This means that you should be very careful with what you test using WebDriver. You should probably not test everything that is possible to test from the user interface. WebDriver is a wonderful tool in many aspects, but it is a slow tool. At least slower compared to other test techniques, such as unit testing. This means that most of the testing in your application should be done using other tools than WebDriver. It also means that most of your testing should be done on levels other than on the user interface. Does this mean that all we have looked at in this course is wrong? Not by any means. It means that you must know when to use different tools. It also means that you may have to divide your test suite into 2 or more different sets. One that is fast, that will verify that the application started and is able to perform the most basic use case. Another one that is slower, and that will test the application more thoroughly. This division is just an optimization for fast feedback and, if you can, avoid implementing it. What is the next logical step after continuous integration? It is continuous delivery, where we aim to deliver our application to production as soon as possible. This is, however, out of scope for this course. But the short description would be to take the artifacts that were verified and make them available to your customers. If you make your product available to your users in many tiny steps, you will get invaluable feedback of what they are using and what they don't use. You will also find bugs that you hadn't even thought about in your tests. Finding bugs isn't that fun, but when they are found, you can add a safety net that will prevent you from reintroducing them again. This is a large subject, and test automation is a part of it, so we will leave it here, and I recommend that you read Continuous Delivery by Humble and Farley. This has been a very, very large section, and we have covered a lot of ground. We have taken a look at a long list of topics and covered WebDriver in great detail. The next section will be about business-facing specification. That is, how can we express what we want in such a way that the business representatives can read them and validate them? Join me there. Welcome back to the fourth section in this video course. This section will be about how to define the natural behavior of the system. We are testing in such a way that the representatives of the business can read and understand what they actually require or the expected feature is. The way we will define the expected behavior can therefore be called business-facing. In this video, we will start implementing the BDD style by introducing Cucumber and Gherkin. This will help us set up a communication channel between the stakeholders, developers, testers, and others. The language we will use for expressing the requirements is Gherkin. Gherkin is a simple language to understand. The language is easy for technical as well as non-technical people. The file is written as .feature extension. In Gherkin, you are expected to define a precondition. This precondition is known as given. The preconditions must hold true. Then, you should define an action known as when. This is where we should use the system. Finally, you have to define what the expected change in the system would be. This is where we assert that the expected change has occurred when the system was used. github.com/cucumber/wiki/gherkin. You may go through the site to dive deeper into the topic. There are various behavior-driven development (BDD) tools such as JBehave, Cucumber, and others. In this video course, we will use Cucumber. This is the site for Cucumber. It is actually a family of tools implemented in many different languages. All of the members in this family are similar in the sense that they all use Gherkin. The difference is that they use different languages for execution of the different steps that are defined in Gherkin. We will use Cucumber-JVM, and the steps will be written using Java. Java is just one example among all the languages that you can use to execute Gherkin. There are implementations in C#, Python, Ruby, PHP, Perl, or JavaScript. Let us visit the below given sites: cucs.info. And the next one is for Cucumber Java. github.com/cucumber/cucumber-jvm. But before we dive into the details, let's ask a very important question. Why? Why should we introduce one more tool and in some situations probably should use? The answer to this question is that no matter how hard we try, the guys who run the business will never understand our test scripts. They will never be able to say if a script verifies what they want to work in an application. It will just never happen. This is one of the motivators behind the idea of behavior-driven development, BDD. We, the developers, can't expect to get an answer that is useful to us if we show them a test script and ask them if this is what they want. They will not be able to comprehend, as computer languages and programming is not their speciality. They are good at other things, but not deciphering Java. Better communication between developers and stakeholders is essential to help understand the expected outcome and crystal clear goal requirement. Gherkin, however, is simple enough for them to understand. It will serve as a tool for communication. This is why a tool like Cucumber is more of a conversational tool than anything else. And this is the reason why the author of Cucumber, Aslak Helisoy, has called Cucumber the world's most misunderstood collaboration tool in a blog post from March 2014. The conversations that are sparked from using Cucumber are the most important and interesting parts. These conversations are unfortunately not possible to illustrate in a good way in this video course, so we will not even try. You will have to experiment and try for yourself. One of the early adopters of Cucumber, Andrew Premdas, has said, "Your Cucumber features should drive your implementation, not reflect it." This has also some implications, the most important being that the features, expressed using Gherkin, should be written before the implementation. As feature is a plain text file, it is easy to understand both for developer and the stakeholder. It also implies that the implementation should be done from the outside in. That is, first define what the system should do, then implement it from the user interface, and then down the stack. If your system uses a database, allow the feature to drive the database implementation last. Well, that's it for this video. In this video, we saw what Gherkin is, we had a small introduction to Cucumber and why we should use it. In the next video, we will jump into an example to learn more about this tool. Hello and welcome back. In the previous video, we saw a brief introduction to Cucumber. I think now is the best time for an example. The beginning of this example would be more of a tutorial in Cucumber rather than a tutorial in Selenium. When Cucumber is set up and works, we will use the same page object pattern as we saw earlier. The page object pattern blends itself nicely into the steps that we will define when we express the expected behavior using Cucumber. But before we can see any business-facing features, we need to set up some infrastructure. Let us start by creating a Maven pom.xml that will contain the necessary dependencies for using Cucumber. The only things that must be added to the pom.xml file we have used earlier and are two dependencies of Cucumber: Cucumber-Java, Cucumber-JUnit. In pom.xml of the Maven project, we should add two additional dependencies for Cucumber. One is Cucumber-Java, and the other is Cucumber-JUnit. We will require these two dependencies to use Cucumber. The next thing we need to do is implement a way to execute Cucumber. Cucumber can be executed in a few different ways. One way that is very convenient is to run it from JUnit. This is a good option since it will allow us to integrate the execution when we build the entire project from Maven. I've created runcucs test Java file for creating JUnit Cucumber test runner in the package com.packedpub.mastering.selenium, which is located at src/test/java folder. This is a very small implementation. Note that it is illegal to do more than annotating the runner class. We are not allowed to implement any methods in it. This is by design. Running Cucumber and implementing the steps that connect the feature, expressed in Gherkin, to the system under test should be separated. This means that we can execute the same thing in a different way if we like. If you implement any methods in the runner class, then the Cucumber runner will be upset and you will get an exception. Let us run it and see what happens. This is our project folder. Shift plus right mouse click on the folder and execute the Maven command. We get a build failure. We can see that something has tried to locate features, but none were found. We get a notification that no features were found at classpath:/com/packedpub/mastering/selenium. This is as expected, because it means that we were able to execute Cucumber, but also that there wasn't anything to execute just yet. But we have an infrastructure that will support us when we continue with the implementation. That wraps up this video. We saw the infrastructure of the tool with the help of an example. In the next video, we will cover the actual implementation. After the completion of project infrastructure in the previous video, we are going to implement the actual Cucumber. In this video, we will add and implement some steps to run the Cucumber project successfully. With the infrastructure in place and working, let's move on to actually implementing something Cucumber specific. Let us start with the first feature. Cucumber looks for files called feature in its class path. We must add at least one feature file for Cucumber to do anything. The feature file should be in the class path. This means that we should add in the resources folder in the Maven project. We will be using it for tests, so we will add a feature file in src/test/resources. Cucumber doesn't just look for features in its class path. It also looks for them in the same package or sub-package where the executing class is located. This means that we have to add the feature file inside the package called com.packedpub.mastering.selenium for it to be found. The name of the feature file is advanceddocumentation.feature. We should add something useful in it. What did we add here? We started out with adding a line that says features, and a sentence that describes what this feature is supposed to do. It is supposed to verify the documentation for the advanced features on Selenium HQ. A feature file must start with a feature. The description is arbitrary, and Cucumber will ignore it. It is only used for communication with other readers. In the next section, scenario, is also arbitrary. I like the user story format, and especially the format proposed by Liz Koef. So if you'd like to, put a user story here. It is optional, but I think it enhances the understanding and communication if it is there and says something useful. In this case, we'll try to describe the business value with Cucumber as a communication tool. The rest of the feature file describes one or many scenarios that are the actual steps that should be executed. The next three sections are really important ones: given, when, and then. Given describes the initial state where we will start our journey. When will be the step where we do something with the system under test. And then is finally the verification step. This is where we verify that the expected action actually occurred. The next thing we must do is to create some methods that can be executed for each step Cucumber finds. We could start with this directly, but there is a simpler way. We can run the build and Cucumber will help us code snippets that can be used as a starting point for the implementation. After adding the feature file, let's run the project. Shift plus right mouse click on the project folder and execute the Maven clean test command. The build was successful, and it also gave us some snippets. Let's copy them and use them. Cucumber will search for the suitable steps in the current package and any sub-packages present. This means that we can hide the steps if we want to. I usually do that, so we will create a package that we will call steps and a class to hold the methods in that package. It doesn't matter what we call the class. Cucumber will search for the steps in all the classes it has access to. This implies that the steps are global. You may react with, global code, but why? The reason is simple. The features describe the expected behavior of the system. If you describe two different parts of the system with the exact same words, then you have a bigger problem than global steps. Cucumber will act as a whistleblower in that case, and you will be able to understand that you haven't defined the expected behavior in a unique way. Okay, let's create the package steps, and in it create the class Selenium Advanced Documentation Step Defs. This is so long that it almost looks like any enterprise system, but at the same time, it describes that this is the home for steps used to validate the advanced documentation for Selenium. And in the class, let's import the missing necessary packages. Let's take a look at the code we just pasted into the steps class. In this class, there are 3 methods, and they are all annotated. This annotation is a regular expression that will act as the glue between Gherkin and Java. The regular expressions will be used to match the steps in Gherkin with the correct Java implementation. We have created the step definitions class, Selenium Advanced Documentation Step Defs, under the package com.packedpub.mastering.selenium steps, and created the step definitions skeleton by pasting the content. Now is the time to implement our Selenium Java code and verify the page title for the page Object Design Pattern. Actually, we are going to implement the page object pattern here. I have created 3 page objects under the package com.packedpub.mastering.selenium.pageObjects at src/main/java folder. There are 3 classes: Selenium HQ, Documentation, and Page Object Design Pattern. These will be used for navigating to the desired page. Let's briefly describe implementing given, when, and then steps. The given steps talks about seleniumhq.org being available. In this step, it will visit the seleniumhq.org and verify the correct page. The next step is the when step. This is where we actually do something with the system we want to test. The page object we created earlier is very handy to use now. Let's create one instance of the documentation for transiting to the page Object Design Pattern, and locate the title of the page objects. We should save the actual value in an instance variable and assert it later. The final step that we must implement is the then step. We are interested in getting the expected heading as a parameter to the method. The reason is that we want to allow someone to change the title on the target page, and the only update we should be forced to do is update the expected behavior that we defined in the scenario. This means that we have to capture the text from the then step. The way to do that in Cucumber is to use a group in the regular expression. We want to capture Test Design Considerations, Selenium Documentation. So, let me replace that part with a group that matches any strings, dot and asterisk. This will capture the expected title, and we can perform a validation using the same hamcrest matches as before. Let's run the build again, and we'll see that it passes. The build has been successful, and our Selenium Cucumber project was executed correctly as well. But did we actually execute the code we expected? Let's change the expected title in the feature and rerun. We'll type Mastering Selenium Testing Tools. That didn't go too well. We had a failure. But this is a good sign since we changed the expected title and the build failed. Pat yourself on the back. We've come a long way so far. There's so much that you've learned. Good work there. Now that we've seen the implementation of Cucumber in this video, let's look at the code organization in the next video. Welcome to the 4th video of section 4 in this course. In this video, we shall cover and organize our code for better maintainability. Test automation is about writing code that verifies your application. It is very important that you organize your code so it is easy to work with. So what does easy to work with mean? I think it should mean that it is easy to locate the right place to do a change. This probably means that the right abstractions are used at the right place. Try to organize your codebase so that the main concepts of your application are easy to spot and, therefore, easy to extend. You may check the book Clean Code by Robert C. Martin and apply all the lessons you have learned there. You can get the book on Amazon. This will help you create a test codebase that is possible to maintain without a Herculean effort. This will also enable you to create a code base with minimum technical debt. At the same time, it is better to start easy and then apply any changes. My approach is slightly different. I differ from separating things in packages in the beginning. I just allow everything to be in the same package for a while, and once I reach a point of clarity, I know exactly what I want. I divide the classes into suitable packages. Business-facing, executable specifications, as we can see here, is a way to simplify the communication between the domain experts who know what should be done and the developers who know how to implement it. Cucumber is one tool. There are others out there that solve the problem in a similar way. The figure of Cucumber testing stack can make you understand business-facing. I have taken the figure from the book, The Cucumber Book by Matt Wynn and Aslak Helisoy. If you feel that Cucumber isn't the best tool for you, experiment with other tools and use the tool that you are comfortable with. I feel that Cucumber is a great tool, but you may have other opinions. We will look at a tool called Selenium Server in the next section. Selenium Server is a way to run the browser on another computer. Suppose that I, who work on a Mac, must verify something using Microsoft Internet Explorer. We'll need the Selenium Server to make things easy for us. Let's check that out in the next section. Welcome back to the fifth section of this video course. In the previous section, we took our sweet time in understanding behavior-driven development. In this section, we will be getting introduced to the Selenium Server and run our tests remotely. Our first video of this section will look at the introduction of Selenium Server. In this video, we will get down to the basics and answer a few questions that linger around when it comes to remote testing. Why would you want to do remote testing? How do you do it? When should you do it? We will then see how a Selenium Server fits the bill and explore it in more detail. Let us start with the most important question. Why? Why isn't it enough to run the browser locally and see if it works? It is enough to run the application on your local computer if you have all the browsers available. However, testing it on all the operating systems would rarely be the case. A good alternative, thus, is to run a browser remotely on another computer with the correct operating system and browser. In other words, if your website supports Safari on two different versions of macOS and you are on Windows, you still have a possibility to test it if it runs a browser remotely. This is also a way of scaling up your testing. If you can run many tests in parallel with many different types of browsers, you may be able to reduce the time it takes to test a web application. Running many tests in parallel may be significantly faster as compared to running them in serial. Now let's talk about how. You can write your test as usual with your page objects and assertions to get this done. But instead of instantiating a local browser, you will need to instate a remote browser. You will have to tell the remote driver where to find the remote system and the capabilities you want. The capabilities define the expected browser and operating system. Running this will either give you a browser with the wanted capabilities or an error. Then, you should execute your tests with the browser. It will probably be slower to executing it on a local browser, but it will still give you the option to execute the test using browsers that you don't have locally installed. This leads us to the last question. When should we do this? You should use Selenium Server whenever you need to implement cross-browser testing, or when you must do a test with a browser that you don't have installed. For example, if you are testing a website in all preferred browsers such as Chrome, Firefox, IE and Safari, however, one image on your homepage is not showing up when it comes to Safari on OS X. Now, this is a browser-specific bug. You might have to verify whether the specific bug has been fixed on Safari on OS X, but you're using Windows as your development environment. In such a case, remote cross-browser testing would be necessary and will help you verify the bug on Safari on OS X. Selenium Server can have many slaves that it will direct the execution to. This means that it can support different operating systems and different browsers. It can also support the same operating system on different browsers. Microsoft doesn't allow you to install more than one version of Internet Explorer per Windows installation. Selenium Server can thus help you support many different versions of IE if it has access to many slaves with different Internet Explorer versions installed. This is often called cross-browser testing, testing the same things on different browsers. But then how do you do it? We must get hold of the server and run the test to check this out. Let's go ahead and download the Selenium server from Selenium HQ. Go to the download section. We'll need the Selenium standalone server. The most recent version is 2.48.2. Let's download it. Once the download is complete, execute the Selenium server file. Let's go to the command line. The instructions on Selenium HQ say that we need to run the jar file and browse to the directory where the file is located. Type the following command: java-jar selenium-server-2.48.2.jar -roll hub. The arguments say that this instance should have the role of hub that we represent in the command roll-hub. A hub is the reference that a WebDriver instance needs so that it can connect to something. Now execute the command java-jar selenium-server-standalone-2.48.2.jar-roll hub. The output shows that the hub began and is listening to incoming calls on port 4444. This is the standard port for a Selenium server. It is possible to change it, but we'll leave it to 4444 for now. GridHub is up and running. We can now open up a browser and examine what we can find at the local host :4444. 1. Open a browser and visit http://localhost:4444/. 2. Observe the information in the page. We are using the Grid version 2.48.0, and there is a link to a wiki page where we can find more help if we need it. Click on the More Help Here link, and you will be transferred to a GitHub page on Grid. github.com, Selenium HQ, Selenium, Wiki, Grid 2. Grid Wiki is the best site for learning and gaining more knowledge. Now, let's open a new tab. Go to localhost:4444. We can see the configuration if we click on the console link. Click on View Config to see the configuration settings for our Grid console. Well, that's all for this video. In this video, we saw how we can solve many questions of how and why we need to make use of the Selenium server. We then downloaded it and executed it by starting a hub. In the next video, we will start registering nodes to actually see how we can run tests on a Selenium server. Welcome to the second video of this section. In the previous video, we got familiar with the Selenium server and downloaded it for testing. This video will help us dive into it and see how it works. In this video, we will start by registering a node and then move ahead by running the server both locally and on a remote browser. In the previous video, we started the hub, but we can't really use it for anything. We will have to attach one or more nodes to it. A node may be one computer and possibly many browsers. Each computer can, for instance, host a few Firefox instances. They can never host more than one Internet Explorer, since only one IE version can be installed at any time on a Windows system. Now is the time to register a node. Before registering a node, let us start the hub. Go to the directory where Selenium server jar file is located and execute the following command: java-jar selenium-server-standalone-2.48.2.jar -role hub. So now Selenium Grid Hub is up and running. Now is the time to start a node. Let's open a new command line and register a node. Go to the directory where the Selenium server jar file is located and execute the following command: java-jar selenium-server-standalone-2.48.2.jar -role node-hub localhost :4444/grid/register. So the node is registered to the hub and is ready to use. Let's take a look at the grid again with a browser. 1. Open a browser and visit localhost 4444. Now, registering the node changed things, so go to the console and view the browsers. The grid now seems to be able to support 5 instances of Firefox, 5 instances of Chrome, and 1 instance of Internet Explorer. We can surely use Firefox, however, we cannot use Chrome because we haven't set up the path to Chrome. It is possible to configure a node from a JSON file, however, it is out of scope of our current course. You will have to explore it yourself. I think it is now time to revisit our example and update it to use a remote browser instead of a local one. In this minified example from section 3, before we make any changes at all, let us verify that it still works with a local browser. Open the project folder in the command line and run the maven command to execute the project. So, running the test locally gets us a build success. What do we need to change to be able to use the remote driver instead? We obviously need to change how we execute the browser and driver. We must specify a URL where the remote browser can be found and the capabilities we would like to get access to. Here is the URL. URL equals new. URL dash, and the parameter is http://localhost:4444/wd/hub. The capabilities we want is a Firefox browser and nothing more. It can be specified as capabilities. Capabilities equal desired capabilities.firefox. And finally, a remote web driver. Instead of Firefox, we have used a remote WebDriver with the parameter of URL and capabilities. Driver equals new remote web driver bracket URL, capabilities, close bracket. So this time, instead of a new Firefox driver, we have used a new remote web driver with the parameter of URL and capabilities. This test is ready for running remotely. Let's see if it works. We are in the project folder, and let's run the maven command: mvn clean test. Build success. Look at the terminals where the hub is started. it got a request from a new session, and the terminal where the node is started. You can see that the node is also called. This is very cool, isn't it? We made very few changes on how the browser is created, and all of a sudden, we're able to run a remote browser. If this hub was started on a remote computer and had many nodes, all with different capabilities connected to it, we would be able to run this test using any browser on any operating system. So far, we have learned to register a node and run a few tests on a remote computer. In the next video, let's try the same thing with an external service. Welcome back to this third and last video of Section 5. In the previous video, we ran a few tests on the Selenium server. In this video, let's try the last case, to run some tests on the cloud. Let's take the example we worked on in the previous video and change it again. Let's try to run the same thing with an external service that allows you to connect to a hub on the cloud. There are various providers that will allow you to run your test on the cloud. We'll be using Source Labs for our test. These providers have been prepared with a Selenium hub and allow you to connect to them and run your tests there. This is great if you want to outsource running a Selenium hub. Your core business is not to maintain and make a Selenium hub available, so running the tests somewhere else makes good sense. So how do we get access to Source Labs? We go to www.sourcelabs.com and sign up for a test account. Let us change our test to use Source Labs instead. You'll have to prepare your own account. I already have an account, so all I need to do is to change the following URL. I'm using my personal access key. I will set the host to be ondemand.sourcelabs.com and the resource to be wd/hub. The portion after http:// is my Source Labs username. Ripan al-Wazim. Let's run it and see what happens. We are in the project folder, and let's run the example. The test is running in the background, in Source Labs. It takes like forever, and nothing seems to be happening. But something is indeed happening in the background. It is happening somewhere remote, which we can't see on our local computer. There you go, build success. The test passed. But we didn't really see anything, did we? When you use Source Labs, you can see the execution later on their website. Let us look at the last test at Source Labs. Browse to Source Labs, log in, and look at the latest tests. Let us take a look at the screencast from my latest test. The test status shows that it's complete. Let's run it. We didn't specify anything, apart from the point that we wanted a Firefox. We've got a Firefox, and we've got it on Linux distribution. Let's look at the logs. On Source Labs reveals that they are running a Selenium server, pretty much the same thing we executed locally. We seem to use the same toolset, but they have the advantage as they provide me with a screencast where I can see the execution. We can also see the metadata here and download it. We have executed the same thing using an internally as well as externally provided browser. What should you choose? I would say that it depends on your requirements at the moment. Factors that you need to consider while selecting the approach of your choice are personal data. You are not allowed to store data about people the way you would like in some parts of the world. Cost. How much does it cost to run the service in-house? Is it worth the money, or is it a better idea to allow someone else to do the hosting? Flexibility. Are you able to provide all the combinations of browsers and operating systems that you should be able to support in-house? There are probably a lot more things to consider, but these are the major pointers you need to think on. How should you behave if your test system is hosted behind a firewall? Source Labs provides a utility that will open up your firewall from the inside and allow you to execute tests on your internal test server. Showing this is out of scope for this video course, but I think it's important to mention when you start to think about external or internal hosting. At the end of this video, we are now going to register a node and run a test on remote browsers. To sum up this section, it is possible, as we saw, not even very difficult to run a browser remotely. Running a browser remotely can significantly increase the number of browsers and operating systems you can test on. It can also speed up the time for test if you are able to run them in parallel. It is possible to host a Selenium server, internally or an externally hosted hub. In this video, we have covered running tests on a cloud. Throughout this section, we took a look at Selenium Server, installing it, working on it, and ran a few tests on our browser locally as well as remotely. In the end, we also ran our tests on an external service. In the next section, we will complete an example using Selenium testing tools. Stay tuned for even more usages of Selenium. Welcome back to the sixth section in this video course. In the previous section, we ran a few tests on Selenium Server. This section will be about creating an entire ecosystem for testing a web application using Selenium. The goal is to present a complete, working example with acceptance testing done by Selenium. It will place Selenium in context and show you how it can be used in real-world commercial development. Our first goal is to set up the project using the necessary tools. In this video, we will test a small web application by using Selenium and Cucumber. We will use Git for source code management and Jenkins for continuous integration. We will implement a small web application, the Google Temperature Converter. The major and first case will be the conversion of temperature from one unit to another, mainly from Fahrenheit to Celsius, or vice versa. This application will be implemented using a set of open source tools that are easily available. You will be able to download, install, and use them when you follow the example. We will, however, not show you how to install them, as this is currently out of scope for this course. The toolbox we will use contains a lot of things. We want to version control our changes. Git is a distributed version control system. It allows several developers to collaborate on one project and keeps track of code changes, so it's possible for developers to work on the next set of features, while testers are testing and automating others that developers claim to be ready for testing. I want to be able to build the system independently from my development environment. Maven is a good tool that makes it easy to get the dependencies we need and, at the same time, build the project using a continuous integration (CI) server. We will use Jenkins as a CI server. It will listen for changes in the Git repository and trigger a build whenever changes are detected. This is very handy, as we will be able to catch any mistakes that were committed early. It is nice if the specifications are clean and unambiguous. We will use Cucumber so that the specs are both executable and human-readable. This course has been using Java all the way, and we will do the same in this example. Java is a common programming language, and many systems are developed and maintained using Java. We will use test-driven development, TDD, whenever it fits. JUnit is a common unit test framework, and I see no reason not to use it. If you are not familiar with these tools yet, I hope that you will find them easy enough to use and be familiar with them by the end of this example. The application can be described with this feature. To convert between different unit of temperatures, we will implement this from the outside in. This means that the scenario above is a good start for us to start coding. Our first action is to create the Maven project as well as a Maven project file, pom.xml, by using IntelliJ IDEA. Open IDEA and create a Maven project named Temperature-Converter. Create a new project. This is the Maven project. Next, input the group ID and artifact ID as temperature converter. Click Next. The name is the same as well. Finish. This is the Maven project structure. And there's a pom.xml, and this is the common skeleton and content of pom.xml. We will add more things, some necessary dependencies in pom.xml during the actual implementation of the project. Let's run the initial project from the command prompt. mvn clean install. So, our initial project build has been successful. Our next action is to place the project under version control. Now is the time for Git magic. Execute git init for initializing the repository. We are now able to save each step we do using Git, and are able to revert to the last working state if we make some kind of mistake. Git is a very powerful and flexible SCM tool. It is designed to handle everything from small to very large projects with speed and efficiency. Open IDEA and go to the project directory. We don't have to version control all files. Specifically, we shouldn't version control the project files that IDEA creates. So, let's ignore .idea files, .iml files, and the target folder. Create a .gitignore file in the project folder and add the file types that we wish to ignore. They are used by IDEA and Maven and are not important for anyone else but us as developers. We will not share or force anyone else to use these files. Let's commit these changes now by using Git. Let's check the Git status. It seems that there are 2 untracked files indicated in red, so let's add these files to the repository. Git add dot. Check the status again. Now both files are green, so both of them are ready to be committed. So let's commit pom.xml as well as .gitignore file by using the git command git commit -m. Type the message, "This is my initial commit." There you go. All the files have been committed successfully. That's all for this video. We now have the required tools installed for a web application and created the project structure. In the next video, we will look at the implementation of this project. Welcome to the second video of Section 6. We are at the starting point of the implementation after creating the project skeleton. In the previous video, we saw that we have all the prerequisites ready for our working application. With the project defined, it is now time to start the implementation. In this video, we shall focus on writing a test case using Cucumber, which will be integrated with Selenium WebDriver for web application testing. We will look at implementing the first use case, conversion of temperature from one unit to another, writing feature of first use case and executing it with Cucumber. I prefer implementing it from the outside in. If we can, and in this case, it should be pretty straightforward to at least define a model in this manner. We have already specified the first feature. It is now time to implement it. The first use case is to convert temperature from one unit to another. We will specify it with the feature we saw earlier and execute it using Cucumber. Let us start our journey step by step. The first step is to implement this feature file. Let's create a file named conversion.feature. It should be placed in the same package or sub-package as the runner class. We will place it in the package com.packedpub.mastering.selenium under src/test/resources. The first scenario in the conversion feature would look like this. Let's commit the file now. Check the Git status as usual. There are again a few untracked files. Let's add those and check the status again. Now let's commit our feature file. Git commit -m initial feature. Our file conversion.feature was committed successfully. Features like this one cannot be executed without some glue that connects them to the system under test. The glue will connect the feature with the rest of the code. There are many different ways to run Cucumber. One is to use JUnit and execute it using a special JUnit runner. This is an easy solution, and since I prefer simple solutions instead of complicated ones, we will use one here. Let us add run kooks test in the package com.packedpub.mastering.selenium. We must add a few dependencies in the pom.xml file. These are all the dependencies we'll need while running the project. In the run kooks test, the class must be annotated with the JUnit runner that will run the Cucumber features. This is all that's required to be able to execute the features found in the feature file. Let's run this and see what happens. Run kooks test. It is still in progress. However, looking at the output, it seems we have missed a few steps. These are the missing steps and a few suggestions. So Cucumber was able to find the feature and begin its search for matching steps. None were found, so we got some code snippets as suggestions. There are not enough, but they are a good start. The suggested steps must be implemented somewhere. Let's create a class and call it conversion_step_defs in the package steps below run kooks test. These steps will be called when the feature is executed. This is our entry point to the rest of the code that will implement our temperature conversion. Let's run the feature again. Check the log. We have been successful this time. It seems we had all the required steps, but now they log to-dos instead. This is a kind of success, so we will commit the changes and come back to the steps in the upcoming videos. Let's commit the files and see the status. Git commit -m added pom.xml, added Cucumber glue code, and step definitions file. There you go. All the files have been committed successfully. At the end of this video, we saw the very basic implementation of the scenario we defined in the first video. In the next video, we will get introduced to continuous integration. Welcome back to video 6.3. In the previous two videos, we set up a small project. It almost doesn't do anything at this point, but it will soon do a lot. This may be a good time to introduce continuous integration, CI, which is the topic of this video. In this video, we will make the Jenkins for our small project. What is CI then? CI is a practice where all the code is changed and a version control system is built as soon as the change is found. This helps us catch compilation errors, broken tests, and similar problems at an early stage. There are many CI servers available. One of the most popular ones is Jenkins. It is a free and open source server. It used to be called Hudson, but was later forked and has gotten a new life as Jenkins. Let's download and set up Jenkins to monitor our project. Download Jenkins on your machine from this site. I have a Windows machine. You may download according to your operating system setup. Open the command prompt. Go to the installation folder and run jenkins.exe. Start. Jenkins is now up and running. Jenkins should be available at localhost:8080. It is actually easy to get a CI server started. Our next task is to prepare Jenkins and add a job in it so we can monitor our project. We will use Git for version control. This means that we must download and install a Git plugin for Jenkins. Jenkins is built around plugins, and there are many of them. Let me locate the Git plugin and install it. Go to Manage Jenkins, Manage Plugins. Under the Available tab, search for the Git plugin. Tick the Git plugin. Jenkins must be restarted to enable Git, so let's restart Jenkins. Jenkins is being installed. There you go. The Git plugin was installed successfully. We will use Maven for building. This means we need to install Maven as well. Support for Maven is built in, and all we need to do is select the version that we want and where it should be downloaded from. We will use the latest available version, install it from Apache, and call it Apache-Maven-3.3.3, since that is the latest version while this screencast was produced. Go to Manage Jenkins. Click on Configure System. Open the Maven Installations tab. This is how you set up your Maven. Let's save our configuration. With the infrastructure handled, let's use it. Let's create a new job. We'll call it temperature-converter and set the type to be a Maven project. So, the job has been created. The project is version controlled at temperature-converter. Select the source code management as Git. Setting the repository URL to the root where the project exists works just fine. You could of course host the project somewhere else. We have hosted the project on github.com. This is the repository URL. Copy it to the Jenkins repository URL tab and save it. Jenkins can poll the version control system for changes. The interval is defined using a crontab expression. We want to pick up changes frequently, so we'll set this to as often as possible. The shortest time we can set is every minute, so we'll do just that. Jenkins will complain about the frequency, but as we want fast feedback, we will ignore the Jenkins complaints. Let's set the project room POM and the Goals and Options tab. Set the lifecycle phase that we would like to execute once the build is done. We should delete the build files and completely rebuild the system. So, set the Goals and Options tab to Clean Install. Clean and Install are the two goals that go well together. Clean will remove any build artifacts, and Install will rebuild them along with installing them in your Maven repository. After making the necessary configuration changes, let's save it. Before running the first build in Jenkins, let's commit and push the code in the global repository. Let's check the Git status and add the missing files. Check status again. Now the files are ready to be committed. Git commit -m and add some message. There you go. Our files have been committed. Now let's push it in the global repository. Here, the remote origin already exists, and it's time to push it to the rigging master. Type the following command and add the username and password for your GitHub page. Good work! Now it has been pushed into the global repository successfully. With these settings in Jenkins, let's run the job manually. It should work as expected. The build is being executed. Let's see the result. See, it worked. The build was successful. Let's check the console output. So, running manually worked fine. Let's see if Jenkins picks up the change in Git. We will introduce the change and wait. Jenkins should pick up the change in a minute, on MRS within 30 seconds. The simple and hopefully interesting change is to introduce a failure. Let's fail one of the tests and ensure the build is broken. Let's introduce a failure at this step. To call the fail method of JUnit, we should mention the import static org.junit.assert.fail. After introducing the fail, let's commit the change. Check the status. Add the files. Check the status again. So the file is ready to be committed. Let's commit it and introduce the failure. So the file has been committed successfully. Now let's take a look at Jenkins. Jenkins is not picking up the change. It may be because we haven't pushed it yet. Let's push it to the global repository, git push, and the Git username and password here. And it has been pushed onto the global repository. So let's observe the build in Jenkins. Great, Jenkins picked up the change. However, the build did not fail. It was only set to unstable. Why did this happen? It turns out the Jenkins has a built-in behavior that it doesn't break the build if a Maven build is unsuccessful. Let's change that. The global options for Maven should be set to -d maven.test.failure.ignore equals to false. Let's see the console output. Well, as you can see, there are test failures. Here's the fail that we had introduced. Let us set the global options for Maven to fail a job when Maven fails. Go to Manage Jenkins, Configure System, then open up Maven installations. The global Maven ops should be set to -d maven.test.failure.ignore equals false. Now, save the configuration file. It seems like a bug to me. However, Jenkins has always behaved in this manner. After setting up the global ops for Maven, let's build it manually one more time. So you may see the build actually fails now. Let's observe. It should fail. It failed. This is exactly what we expected. Let's fix it now. If you observe the console output, you'll notice many errors exist. We had purposely introduced an error, so fixing it is quite simple. Let's remove this line. Now, save and commit it. Check the status. Add the file. Check the status again. Commit it. Add a message. Fixing the failure. Now, let's push it to the global repository. Add username and password. Now the code has been pushed, so let's go observe the build in Jenkins. The build was executed automatically, so let's check its status. The build was successful. Jenkins is happy, and now we know that the build will fail whenever Maven fails a build. This was a short introduction to continuous integration, CI. It is so easy to get started, so every project should have a CI system in place to build and monitor their code. This is the starting point of many interesting applications, one of them being delivering an application often, possible on every commit. This is, however, the subject for a totally different course, and we will not dive deeper into that. We have done the coding skeleton of Cucumber. Also, setup and configuration of Git and Jenkins has been completed. Let us continue implementing the rest of the system by integrating Selenium WebDriver in Cucumber. Implementing the tests for web application is the topic of the next video. See you there. Welcome to the fourth and last video of Section 6. We have so far configured Jenkins, Git, and Maven. We have also introduced the Cucumber code. Now, we're going to the real-life implementation of Selenium Web Test integrated with Cucumber. It is time to focus on the user interface and use it. Selenium integrated with Cucumber is a good and strong tool for testing the user interface. In this video, we will focus on UI test with Selenium and Cucumber in BDD style. Obviously, it will cover the acceptance test. We are using Java, and there are not too many lightweight web frameworks available. Before we implement the test automation, let's look at the flow to be used at a glance. The UI design of the page is as below. A drop-down for selecting the category. The temperature is selected automatically. A text field for entering temperature value in Fahrenheit. A text field for showing the result in Celsius. Two drop-downs at the bottom to select unit, one for Fahrenheit and the other for Celsius. After entering the Fahrenheit value in the text field, it will be converted into degrees Celsius. The window is where the result will appear. This should be pretty easy to implement, test and verify. I want to convert 98.6 degree Fahrenheit, the normal body temperature, to Celsius. The Celsius value would be 37 degree according to the equation C by 5 equals F minus 32 by 9. I have done the assertion in my code for verification. We will see that during the code analysis. But before we can do anything, we need to add Selenium support to the project. Let's add a dependency in the POM for Selenium support. This is the dependency portion of the pom.xml file. This is sufficient for us to implement the interaction with the web page. With access to Selenium, it is time to do the actual implementation. The first thing we do is to add a page object that will interact with the conversion page. Let's call it the temperature converter page. Remember that we've used the page objects to hide the complexity of interacting with the web page from our test code. There is another page object named Google. Google should take a WebDriver as a parameter in its constructor, and it should connect to www.google.com/ by using driver.get method. The method go to temperature conversion page will return the temperature converter page object, which is the main page for our action, that is, conversion of temperature. We should also know whether we are on the correct page. A simple way to verify that is to check the page title. If it is the wrong page, we will have to stop the execution. A simple way to halt the execution is to throw an exception. So let's add a condition that verifies the correct page title for both page objects. If the page title is wrong, throw a wrong page exception. We should avoid using checked exceptions whenever we can. The exception we have extended here is the runtime exception. When the exception inherits from runtime exception, then we don't have to declare that it was thrown in new methods. This is pretty much what we want. If we were to end up on the wrong page, we should stop the execution. We shouldn't force our entire call stack to declare something that indicates a clear error. Let us look at the page objects, how the wrong page exception has been implemented, and the Google page. As you can see, we have implemented the wrong page exception. And on the temperature convert page, this area is where you should implement the wrong page exception. These changes should not affect the rest of the program. We can commit them. So, after changing the pom.xml wrong page exception, and after creating the page objects, let's commit the code. Go to the project repository and commit. Before committing, we need to add the missing files. Type git commit -m, updated pom.xml and initiated the implementation of page objects. The files have been committed successfully. We have created the skeleton of step definitions in video 6.2. Now we have written our necessary snippet of code in conversion step defs class. There are three methods. At the rate given, a noted method. At the rate when, and at the rate then. So this portion of the code is for page transition. After moving to the correct page, input the Fahrenheit value and it will be converted to the expected Celsius value. This method is responsible for inputting a value in Fahrenheit. After it has been converted, the step that remains is its verification. For verifying the result, we have made an assertion by using assert equals. Check this line. Now, let's execute the final commit and push it to the global directory. Check the git status. Then, git add dot. Again, the status. Then, let's commit git commit -m, modify step definitions. And finally, let's push the code git push. Username and password as usual. There has been some error. Let's try again. The code has been successfully pushed. The next step is to observe the execution in Jenkins. The implementation of our small web application is done, and it's in the global repository. Now is the time to observe Jenkins. Yes, Jenkins has picked the build and it is being executed. It should pass. Whoa! It has passed! Let us visit the console output. There you go. The build was successful. That's all for this video. Phew, that was a lot. All the necessary steps have been taken for implementing the test of our web application, and it was executed well in Jenkins. Join me in the next and last section of this video course, taking a journey on advanced usage of Selenium and a look back of this course. Welcome to the seventh and final section of this video course. In the previous video, we took a look at a complete example, which should be sufficient information for you to try out all the techniques on your own application. In this section, we will take a tour of the advanced usage of Selenium, a look back at what we've covered in the course. This video deals with the advanced usage of Selenium. And the question you may have is, what is left that could be more advanced? Let's take a step back and ask ourselves what is advanced. I think advanced will be anything that is somewhat more complicated than you know at the moment. In other words, it depends on your current knowledge and what you expect to use the tool for. We have covered many details about interacting with a web application and how to assert a lot of different things in this video course. Some of this can definitely be considered advanced. Selenium is all about automation, so I assume that advanced at this stage would mean automating something you didn't expect to be automated using Selenium. We have already discussed some common advanced topics available at the following location: docs.seleniumhq.org/docs. github.com/seleniumhq/selenium. Let's take a quick look at them. Moving on, let's peek at a few more advanced usages. The first one is semantic verification. Selenium can be used for semantic verification of a service. It is common to verify that a server is up and running using different monitoring tools. Nagios is one example of a monitoring tool. The problem with them is that they usually only verify that a service is up and running. This is obviously important, but it is not enough. It is not enough to know just that your server isn't down. What you really would like to know is, can my users use the service I provide? Well, how can you know that? You can know that by monitoring the logs and see that you have the expected traffic. You could also monitor it by simulating an important path through the application. Since it is a web application, Selenium is a perfect fit for this case. You could define a smoke test that is executed from Nagios that simulates an actual user. You may want to verify if it's possible to select an item and put it in a shopping bag. You could also perform a purchase. Performing a purchase may surface other problems, such as the issue with valid credit card information in your source code. But it could be done, and you would know pretty soon if you had an important production bug or not. Performing a complete purchase would verify not just your application, but also the interaction with third-party payment providers. Even if their production isn't strictly your problem, you are affected in a very high degree if they are down. You want to make them aware of this as soon as possible if that is the case. A customer of mine is using a tool called Service Manager, an ITIL tool for tracking changes in their environment. It seems like a heavy tool to use, and one of the guys working with it has tried to automate creating the changes with Selenium. I'm unsure about the final outcome, but automating your job using a browser automation tool like Selenium is definitely an advanced usage. I have used WebDriver to add test users to a system for one of my clients. Whenever we refresh the test database in the test environments, we also had to add a set of test users. We did an attempt to add one user and spied on the database to see if we could understand what was changed. The product running the database was a third-party product, and we didn't know all the details of how they used the database. It turned out that adding one user triggered some 300 database changes. The DBA and I then realized that this would probably be complicated. It was, however, not complicated to browse to a page where we could add each user. Automating it with WebDriver and the headless HTML unit driver turned out to be easy. So instead of understanding a third-party implementation of a database operation, we used the web interface they supplied together with a headless browser. The entire process was executed from a build server running TeamCity, so we couldn't expect to find a browser on the system. Using the HTML unit driver turned out to work more or less perfectly. For TeamCity, you can visit www.jetbrains.com/TeamCity. Advanced usages of Selenium tend to include automation, and when you know Selenium, it isn't really advanced. It is often more of the same as any other functional test of a web application. The biggest difference is that we don't test the application, we are using it. One potentially advanced usage of Selenium that I have heard is load testing. I am pretty sure that it would be the wrong approach. Running a browser would be a very ineffective way to generate load. There are many other tools out there that specialize for generating load, JMeter being one of them. So load testing is an area where I currently don't think Selenium will ever be the right tool. FlexMonkeyum plugin for Selenium IDE allows you to record and play back FlexMonkey tests using Selenium. Selenium RC has an extension, Flex UI Selenium, but unfortunately there is no extension available for Selenium WebDriver. Some of the tools based on Selenium WebDriver can be used for mobile application testing. Share your war story with the community. Write a blog post about it. send an email to the Selenium users list at Google Groups. The address is given below. Let us visit the forums for a while. You can post your questions and expect answers of common problems here. To sum up this video, advanced usage is only advanced until you don't know how to use them. Once you understand them, things become very easy. We have looked at many different ways to automate web applications using Selenium in this video course, and most of the applications I have mentioned here should not seem very advanced to you anymore. They may have seemed advanced one day, but I'm sure it's not anymore. In the next video, we will sum up the entire course and see how we can go beyond with Selenium. Welcome back. This is the last video of this video course. In the previous video, we spoke about a few advanced uses of Selenium. We will sum up what we have covered in the course and highlight some of the important aspects. The first and probably most important thing to remember is that Selenium is not strictly about testing. It's about controlling a browser. Controlling the browser allows you to test web applications, and this is our main usage of Selenium. The purpose of testing web applications is to be able to release new features frequently and know that we didn't break any existing functionality. In other words, to know that we didn't mess up something when we added something new. We started out with Selenium IDE. It's a Firefox plugin that will allow you to record and replay a journey through your web application. Selenium IDE is great to start with when the threshold before you get something up and running is low. The downside is that you can only use Firefox. If you wish to test your application with other browsers, you have to use another flavor of Selenium, which is WebDriver, instead of Selenium IDE. Selenium IDE is a starting point, but not an endpoint. WebDriver is the tool you should use if you need to pass your application with any other browser other than Firefox. WebDriver is a library that you can use to control a browser from a programming language. You can write some code to control the browser and get information back from the web page. The languages supported are Java, C#, Ruby, Python, Perl, PHP, and JavaScript. Using WebDriver means programming, so you must have some programming skills. If you are getting started with it, team up with somebody who knows and share their knowledge. With WebDriver, you can control many different browsers. The browsers that are supported are Firefox, Chrome, Internet Explorer, Safari, and Opera. There is also a headless browser, a browser without user interface that you can use. It is called HTML Unit Driver. A headless browser is sometimes a very good alternative because it is fast and always available. And because you can run your scripts on a Linux box in your test servers, the other browsers that are supported must be installed on the computer where you are running your scripts. WebDriver doesn't have any verification framework bundled. You will have to add one yourself. I used JUnit in this course. Other popular and recommended verification frameworks are TestNG and Spock. When you write your test code that will verify the web application, make sure that you separate navigation and verification. It is very easy to mix them up, and if you do that, then you will create an unnecessary maintenance problem. Instead, separate navigation and verification with a page object pattern. The page objects will handle all interactions with web pages and will be controlled from a test. This means that you can reuse navigation in many tests. It also means that you can update the navigation in your web application without updating many tests. All you have to update are the page objects that interact with the changed pages. Separating navigation and validation also means that you can change the test framework without too much problems. Maintenance is greatly simplified if you use page objects. The WebDriver interface is okay for most navigation. It is, however, not enough for more advanced interactions. Many of the advanced interactions that you need to have support for are located in the Java package org.openqa.selenium.support.ui. Look there when you want to interact with a select element, or if you need to wait for an element to load on a web page. You can write your own tests in the business-facing fashion by using BDD tool. We covered Cucumber in this course. There are other tools available for behavior-driven development, such as JBehave. Cucumber can help you write specifications by using examples in plain text that anyone can read and understand. If you want to scale up your testing, then you should use Selenium Server. It was called Remote Driver and Selenium Hub, but it is now known as Selenium Server. Selenium Server allows you to run your tests on another computer and on a different operating system. This means that you can test your application both with Internet Explorer on Windows 7 and Safari on OS X. If you really want to scale up and not spending time running a Selenium Server grid, then use an external provider that gives you access to many combinations of browsers and operating systems. We saw an example where we use Source Labs. Check sourcelabs.com for more details. BrowserStack provides a similar solution. Do check browserstack.com as well. I hope you have enjoyed this video course and have already started poking around with Selenium and WebDriver. Watching a course like this will give you a good start to make you a proficient user. You sure will have to do the heavy lifting and start using a tool to learn it and get better. The best source for information on Selenium is available on Selenium's official website, seleniumhq.org. The Selenium mailing list is another source of information. Join the discussion there and learn Selenium by helping others. Teaching is a great way to learn anything. If you are able to teach others things about Selenium, then you will be able to learn even more yourself. Remember, sharing is caring. Happy hacking! If you have any questions for me, please feel free to contact me at the following email address. I hope you've learned a lot from this video course and will be using all the knowledge to do even greater things.